out. Okay. Okay, so this is our example here, right? These two examples are going to tie into this last example. Okay, so we said that our inventory here is our array containing these values. Okay, so we want to compare and find out which of our items are out of stock, right? And then so we do that by doing our array equals what? 0, and this will print out our Boolean results for us. So we've assigned that to the variable out of stock. So should we print out of stock? We have our values here, our array with true, false, true, false, true, false, true, false here. Okay, so say we want to count the next example. We are counting how many are true. You remember that I have talked about this, that true is 1 in Python, false is 0 in Python. So you can even add true plus true and get 2, right? True plus true. Right? True plus true is what? 2. Because true is 1 and false is 0. I didn't create this. I didn't do this assignment. That is how it is in Python. Okay. So, so we want to count this example. We are counting how many values are true, right? This is your past. Remember that our past has become, where is it? This one. With this example, right? Our past is now true, false, true, false, true, false, true, false. This is our array that holds our Boolean values. Okay. So that past is what I've copied here, right? Remember that our past is true, false, true, false, true, false. So when you call NP sum, when you call NP sum on past, what is it going to give you? If your past has true, false, true, false, true, false, and each value is truly zero, true is 1. This is what's this list. Can I be heard? Said my network was unstable.
Yes.
Okay, great. So this, do you guys agree that this is the same as this? Do we agree that since the value of true and false is true, false, is 1, 0, 1, 0, 1, 0? Do you agree that this list is equivalent to this one? Okay, cool. Nice. So in the case where you call NP sum on this, you want to call NP sum on this, what's it going to give you? It's going to add the true, it's going to add 1 plus 0 plus 1 plus 0 plus 1 plus 1 plus 0 plus 1. That'll give us 1 plus 1, 2 plus 3. 1 plus 0 is what? 1. Plus 1 is what? 2. Plus 0 is 2. Plus 1 is it will sum these up for you, right? And you get 5. So if you want to count the number of students that passed in there, you can just call NP sum on the past here. After we did our comparison and we retrieved this Boolean, you want to count the number of students that passed. You don't need to do it manually and count. Say you have 1,000 elements, right? And you have true, false, true, false, true, false, true, false, true, false, 1,000. How do you count them? You can't do it one by one. So you do NP sum. You want to find out the student that passed. NP sum, and you put your array here as passed, and it will count those that passed for you, because those that did not pass, those that written false are 0, and so 0 plus a number is still the number. Please, do we understand? Do you understand?
Can you take that again? I think
Okay.
you broke off at the time.
Okay, sure. So we have our should I bring this code down here? Remember this, right? This is our scores, right? NP is an array containing our marks, our scores, okay, for say data science, right? And then we want to find out which students passed this exam, and our pass marks was 60. Okay, so how do you do this? You compare each element to 60, whether the elements are greater than or equal to 60. If the element is greater than or equal to 60, it will return what? True. 72 by 60 will return what? True. 45 compared to 60 greater than or equal to 60 will return what? False, because 45 is not. And like that, and so on and so forth. Okay, so that's how we get our new array, which is passed. So this returns our booleans true, false, true, false, true, false, true, false, right? Because when you compare in Python, it's going to return true or false, whether the logic is true or the logic is false. It's going to return true if it's true, false if it's false. Okay. So in this case, why did I do pass equal to scores? No, I'm not equal to scores. This was originally, I think, passed equals, I just put this here. So our past is equal to the boolean that we got after doing this. When you print your past, you have this true, false, true, false, true, false. So past is your array of booleans that you got after your comparison. Now, say that we want to count the number of students that passed in this list. We said that in Python, true is 1 and false is 0. So if this is your list, your array of true, false, true, false, true, false, your array of booleans here, right? And then 1 is true and 0 is false. True is what? 1. 0 is false. True, 1, 0, false. And false, 0, true, 1, true, 1, false, 0, true, 1. This is what it is. We said that this is equivalent to this because this gives true is 1 and then false is 0. So this is the same as this, right? Okay, that's how you can add true plus true and get 2 because true is 1 in Python. Okay, so in the case where you want to count the number of students that pass, say you have 100,000 value, like 100,000 scores here. You want to count the number of students that pass. See, you finish doing your comparison and you have true, false, true, false, true, false, 10,000 for each element. You can't count it in like by hand and go, okay, this person passed, this person not passed, this person passed, this person. So Python and NumPy have given us a way to do this, right? Because it makes our work easier. Remember, NumPy makes our work easier. So in this case, we want to sum up the number of students that pass. Just count me the number of students that pass. We can't do, we can do this many ways. We can do this. We can use our loop statement and whatever to do this, but no, we are using NumPy. So how do we do this? We just call np.sum into brackets. We have our array, which is what's passed here. All right, let's put this down here. X. So in a sense, what is going on here is 1 plus 0 plus 0 plus 1 plus 0 plus 1 plus 1 plus 0 plus 1. 1, 2, 3, 4, 5, 6, 7, 8. Cool. This is what is going on. You know that when you call NP sum, it's summing up everything within the array for you, right? Do we agree that NP sum is summing up everything within the array?
Yes.
Good. So if we agree that NP sum is summing up everything within the array, if you add 0 to 1, you will still have 1. If you add 30 to 0, you still have 30. This is basic maths, right? Yeah. So if you are summing up everything in here, and everything in here is true, false, true, false, true, false, only the ones that are true is what is going to be summed up, because false has the value of 0. So if you want to count the number of students that passed, it will count the number of truths that it will add up the number of truths that you have, which every true is 1. So np.sum passed will give us, let's print. We'll add up everything here. We'll add up everything here and give us 5. Do we understand how this 5 came about? Lucy, do you get it?
Yeah, I get to know.
Yeah. So all that is going on here is that we are adding whatever is inside this thing. And in this case, whatever is in here is 1 0 1 0 1 0 1 0. And so our 0 is going to be obviously ignored, because 0, if you add 1 to 0, you still get 1, right? So this is like this is like a short, like an easy way to do this without doing a loop statement, and now come and count all the truths that we have. Say if true for I elements in this array, if true is this, now it's a whole lot. Do you understand? So the best way to do it is like this. We use our NP sum to sum up all of our truths in there, and then we have all the students that passed. If the pass mark is changed to 40, it's changed to 40, right? This is going to return a different something for us. Do the sum first. Right? We have true. So if now we say find the student that passed for us, this has now changed to 1, 1, 1, 1. So 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1. And so when we print NP sum, how many students passed? It gives us 8, because our 8 students have passed. 8 students satisfied this condition here. Please, do we get it? Do we
Very well.
Lucy, you get it?
Yes, very well. Thank you.
Welcome. Okay. So on to the next. This is okay, so we have counting how many values are true. Okay, so this is how our past here, we summed it up and we got this. This is just the explanation for that. And now the second one, we want to count the items that are out of stock. This is our inventory, right? We said that we want to find out the ones that are out of stock. So inventory equals 0, and we'll print out our outputs here. When we print out of stock, we get true, false, true, false, true, false, true, false. Yeah. So out of stock gives us Out of stock gives us this array. Out of stock gives us this array, right? We want to count how many items are in stock, right? We want to count how many are in stock. So those that don't satisfy the how many items are out of stock? Sorry, guys. How many items are out of stock, right? So we call our NP sum, but within it, what's happening is that true is what? 1, false, 0, true, 1, false, 0, true, 1, false, 0, true, 1, false, 0. This is what's happening here. So we call NP.sum on our out of stock. It's going to sum up whatever is in here. We sum up this 1 plus 0 is what? 1. 1 plus 1 is what? 2. 2 plus 0 is what? 2. 2 plus 1 is what? 3. 3 plus 0, 3. 3 plus 1, 4. So okay. Oh. When we call NP sum on our out of stock, we get what? 4. Good. Perfect. Right? So we have our 4 here because it has counted, and now we have the number of items that are out of stock. We get this example. Are you thumbsing up and I'm not seeing it? I'm just trying this.
Madam,
Yeah.
please take the last part again. I don't get it.
Okay. Last part. You mean the whole example?
Madam,
just
no, the second part where you got the print out of stock. I don't understand. The 05, 012. That is the array.
Okay.
Do you get me?
Yes. This is the code that printed this one out. Let me just wipe that.
Okay.
This thing echoing. Okay. Hello. Okay. Just going to- Okay. Okay. So we have back to answering your question. That's what this stock levels thing is. That it was just a print statement to print this out so you can compare it to the output. Okay. So this is what we are doing. This is our inventory, which is our NumPy array. We are comparing to see whether anything in here is out of stock. How do we get that? Inventory equals 0. If something is equal to 0, it means asa, you don't have some there. So inventory equals 0. And then it takes each member here, compares it to this 0, and it'll print out true, false, true, false, true, false for those that are satisfied. If something is equal to 0, it's going to print out true. Something is equal to not equal to 0 is going to print out false. Equal to 0 true. Like that, like that, like that. That's how we have out of stock here. We've assigned our out of stock to this inventory, this comparison here. And you know that when you compare in Python, it's going to return what? Booleans for you. So it has returned these booleans, and this is now our out of stock. So when we call np.sum on out of stock, it sums up everything in here in the true, false, true, false, true. And we know that true is false. True represents 1. True is 1 in Python. False is 0 in Python. So this is what that looks like here. It's like we are calling NP sum on this. So it's summing up everything in here for us. And that's how we have our 4 here. So because 1 plus 0 plus 1 plus 1 plus 0 plus 1 plus 0 gives us 4. So we've counted the ones that are true, the ones that satisfy the condition. Angie, did you get it?
Yes, I get it. Thank you.
Okay, cool. You're welcome. Yes, so that's what we are doing here. So this, yeah, that is what we did here. NP sum, we count it and it gives us this. Please, does everyone get it? Do we get this example? I want to make sure everyone is good before we move on. Please, the guys, mind me, okay? Do you get it? Hey, Mohammed, David, Samuel. If you don't get it, let me take it again before we get into something a bit more. It's not, nothing here is complex, honestly. It's just, you just need to get it in and it's good. Okay. So we're moving on to filtering arrays. Filtering arrays. So, so when we use, when we have booleans, right? Boolean indexing. We can use booleans to filter your arrays, okay? So in the case where we have something like our scores here, right? And then we've done some Boolean comparison or whatever, and then it has returned this output for us, right? For this scores. Okay, we've done, say we checked, we did we had a pass mark of say 60. No, we had a pass mark of 50. So those that satisfy the, we had a pass mark of 60, right? So those that satisfy the 60, those are greater than 60 will come here as true, will be printed as true. So our pass mark is 60. Those that satisfy those that did better than 60 are going to be printed here as what true. 72 true, 45 false because it's not greater than 60. 88 is greater than 60, so true. 55 is not greater than 60, so false. 91 is greater than 60, so true. So we have that and we've assigned it to this mask. Okay. We can use this mask to filter our scores. Okay. In the case so when you call your mask on your array here and you put this mask here, we are performing a filtering, right? We are telling it that all those that are true here, return them. Those that are false, ignore them. I'm gonna take it again. Use the example that we used here. No, there's better examples down here. Oh, well, let me copy that. Okay, the first thing we did was with this inventory. No, the scores, scores. Then we count down. Where is it? I'll be using this cell here, okay? So this is our our comparison statement, right? We are trying to figure out which ones, let's use 60, which students did better than 60, right? Or 60, which students made the pass mark, right? You write an exam, sometimes the pass mark is what 60. You want to find those students that got 60 or above 60. So we do compare our scores here. Score greater than or equal to 60, right? So for each score here, it will be compared to the 60, 45 to 60. 88 to 60, right? And then in that case, when we do that and we print, and we've assigned it to the variable past, we print past, it gives us our true, false this. Let me just print. Okay. Okay, so we print past, it gives us our true, false, right? So now this past here, which contains our true, false, we can use it to filter. So in this case, we are not counting the number of students that got this thing. No, we don't want to count it. We want to bring them out and look at them. Or we want to look at their scores. Or we want to, but we don't want to, we are not intending to count. If we wanted to count, we'll just call our MP dot sum on it, and it will count the ones, it will add them up and count the ones that made the pass mark, right? MP dot sum to count. Put that here. To count. Right? But that's not what we are doing. Let me know if you can put it here and come and confuse someone. Okay. Okay. So this will count all those that satisfy this condition true. But that's not what we are doing here. We are trying to make, we want it to filter. We know what a filter is. A filter is like a sieve, right? We have a sieve. We want to take out the students that passed into our sieve and leave those that did not pass outside of the sieve, like as the husk. Leave those ones behind. As the ones that are left behind, right? So this is what our filter is going to do. This is how we use our Boolean array as our filter. So that's basically what's going on here, right? We have scores, which is the original array, and then we open a square bracket, and then within the square brackets we have what our list of arrays. You know that past gives us this, right? Put in hash here first. It's not difficult, okay? Don't complicate it. It's easy. This is easy, okay? Okay. So we have it like this. This is pass, right? So we want to use this pass as a filter to only select those who have passed, right? Those who have passed are the ones that are saying have true. The ones that the Boolean, the operator return true for, right? So here we put our past here. We want to select the scores, the scores that made the pass mark, right? We just want to see those ones. So we call our scores here, then we have our square bracket here, we put pass inside of this. Put pass inside of this, okay? So when we print pass, scores passed, it will give us the list of those that passed. Those that failed, that did not pass are what? 45, 55, 48. Those do not exist in this list. Okay, so we'll just take out the ones that returned false and return only the ones that returned true. Please, do you understand? We are using, after getting our Boolean, after doing our comparison and getting our array of Booleans, we are using that array of Booleans to come and filter our array, our original array, so that we can return those that satisfy the condition. So our condition is scores greater than or equal to pass, greater than or equal to 60, right? Those return these Booleans for us, true, false, and now we are using it as a Boolean, as a filter to come in, just to come and select those that satisfied this condition. That is all we are doing. So this is our pass. We put it in square brackets here, and then we just put the scores in front of it, and then we print it, and we have our results here. So this is the scores that made it. These are the scores that made it. Please, you understand? We'll get to more examples, but do you understand what I've said so far? If you don't, kindly draw my attention. Let's Let's see what we can do about that. Okay. So see, we have so in this case here, with our scores here, say the passback was what, 60, and it has returned. This is a markdown, so we can't do coding here. So we have our scores here, and then we were looking for those that made it that past 60, right? The scores that passed 60. So let me just type what the condition. The condition was mask equals what? Scores. We're not going to use greater than equal to greater than 60, right? Max equals scores greater than 60, right? So then after that, you know that what we printed out is our Boolean list. So that in the bracket. Our Boolean array. Okay. So this will print out true. This will print out what? False, because it's 45 is not greater than 60. 88 is greater than 60, so true. 55 is not greater than 60, so false. 91 is greater than 60, so what? True. This is what we have there. And now we said that with filtering with Boolean indexing and filtering arrays, we can use our max that we found as a filter, so that those that return false will not show up. Only those that return true will show. This concept is very, very important because you will use it a lot. You will use it. Like you will use it. Say you have a data, you can, when we do our projects, you see, but like you have some data, I keep using students' data because, like, yeah, but your students' data, you're a teacher, for instance, and you get students' data, and then the teacher is asking you, okay, I want to find out the students that's made the pass mark, right? How do you do this? Boolean indexing is how you're gonna do it. You derive it could be a list or whatever, but here we are working with arrays. So we derive your array of booleans, and then for that have satisfied the condition. Like after doing this condition here, this comparison here, you get your output here. Then you use it as a filter. So wherever you call this scores and square brackets, and then you put your mask in here, it will filter out those that returned true within this max. Only those that gave true. Those that returned false are not going to be returned. Are not going to be returned. Please, do you understand? It's just simple and straightforward. It's just the square brackets. It's how you want to filter. You've created your Boolean. Now, what's your original data? You have that one outside. Then within the square brackets, what you put that in that. You are saying, okay, so we have scores. So within scores, pick out those that satisfied max. And then it will give us this. That's all. Please, you get it. Please, you get it. No?
Madam,
Yeah.
go over the mask again. I understand up to where you wrote the mask is equal to the scores greater than 60. Of course, it will print out mask and then give us that the booleans that fulfill the condition. I get that part. But the filtered is equal to scores with the mask. I don't get that. Is it?
No. We are just assigning, okay. We are just assigning our results, whatever results here to this filter. So please, if this filter is what is confusing you, let me wipe it. Why? We are just doing an assignment so that it will hold, whenever we print filter, they will just give us our output.
Oh,
Do you get it? Yeah.
yes.
So this is just our results. You can just print it as it is, but you can wrap it in a you can put it in a print and you can also assign it to a variable. However,
Yeah.
we want to do it. Okay.
Right.
Yeah. So David, let's
Okay.
hear you.
Yeah, I wanted to ask, you see with the filtering arrays, the mask. So,
Mhm.
see when you assign mask to scores greater than 60 and then the true false part, and
Mhm.
then you mask the scores, is it by default that it returns the true
Yes,
values?
yes.
Okay.
By default, it will only return true. Only every single time it will only return true. So if you intend to get a different result, you have to make sure your comparison is different. Say you want those that did greater than 60, right? I need to put this code somewhere. If I work with it. Those that did better than six, no, less than 60. You want to find those that did not pass. You have to change this such that your true or false, true or false would return those that did not pass. Okay, so we want to find those that did not meet the pass mark. What would that be? That would be less than 60. Should be um less. Ew. Less, right? So pass now, no, we're gonna call it what? In fact, let me call it failed. Sorry, but yeah, failed. Okay. So this right, failed. Okay. So in the case I want to find those that did not meet the pass mark, right? So those that score less than 60, right? People want to lash them. So we want to see the those that scored less than 60. So we go cos less than what? 60. And with this, it will compare. Is 72 less than 60? No. So 72 does not mean. So 72 give us what? False, because it's not less than 60. It's 45 less than 60? Yes. It will return what? True. Let's do the. Huh. 72 less than 60, or return what? False. 72 is greater, so no, false. 45 will return what? True. 88, false, because it's greater. Um, what? Uh, 55 will return what? True, because it's less than 60. 91 false, 63 false, 48 will return what? True, because it's less than 60. Then 76 will return false. So these are the students that we are going to kill. It's not their names, it's just their scores. These are the ones that we're going to kill. All these true people. And we have three of them here. If you want to count that, you go with your MP sum, but we don't want to count. We want to see their scores. Okay. So in this case, we print our field and we have this here. Field gives us false, true, false, true, false, false, true, false. And I want to use that to filter for those that failed, right? Now we have our scores here, and then we put our square bracket and we put our field here, right? Then it will filter for those that's got true. That's the condition returned true for. So only the true ones are gonna make it. That's why when we print it, we have 45, 55, and 48. These are the students that failed. Please, do you understand? So depending on your condition, the thing is always going to filter for those that got true. That's returned true every time. It's only going to work for true. It doesn't work for false. You can't turn it around and no. It only works for true. Do you get it? Please, is your question answered?
Yeah, I get it.
Okay. So I want to look at some examples, right? Please, if you get it, we're gonna do this together, right? Okay, so we have an array. If you missed something, kindly pay attention here, okay? We have an array of ages, which has these ages here. We want to find out which people are adults here, right? Who are the adults here? To be an adult, you need to be what? Older than 18, right? 18 or above, 18 and above, right? So ages, we have our ages here. Then we want to find those that are 18 and above. So we use what? Greater than, equal to. right? So then they do it. Sorry. A, yes, just want to make sure I got my operator right. Okay. Greater than or equal to 18. So everybody that's greater than or equal to 18 is what? An adult. I'm going to assign it to the variable what? Adult. Okay. I'm gonna put in a bracket. Even though if you don't, it'll still be fine. Well, we're gonna put in a bracket so that it knows that this whole thing is being assigned to this. Okay. So here, students that made it past this student A, people that are older than 18 are what? Adults. We've assigned it to the variable adults. Let's print adults and see what comes. I'll call someone, you guys, to do these two for us. Because, yeah. Print with adults. What does it return? 12-year-old is not an adult, so false. 18-year-old is an adult, so true. 25 is an adult, so true. 16 is not an adult, so false. 30 is an adult, so true. And 14 is not an adult, so what? False. Now, say I want to count those that are adults within this list. How do we do this? We go with our MP dot what? Sum. So we have this adult here. NP, this is not what we are working on, but I just want to do that. Okay. NP dot sum, and within that we have our adults here. I'm gonna print that. So we see those that are adults here. Okay. And we have what? 3. Because we know that false is 1, false is 0, true is 1, true is 1, false is 0, true is 1, false is 0. So if you add 1, 0 plus 1 is what? 1. Plus 1 is what? 2. Plus 0 is what? 2. Plus 1 is what? 3. That's how we have this 3 here. Okay. That's what we are doing. But yeah. Now I'm going to we're going to filter. We're coming to filter for those who are adults. How do we do this? Very simple. Ages. Then we have our filter here. Can go like this. Go like this. It will go like that. And then we can print it. And it will give us those that satisfied true. So we see 18, 25, and 30 are the adults here. Please, do we understand? If I don't see your thumbs up, it means you don't understand. And you unmute and tell us why. Why? What's your problem? Tell us the reason what you don't understand so that we will explain to you. Samuel, do you understand? Somebody has been going in and out of this call. Bernard, do you understand? Or should we take another example?
I'm
Bernard,
coming. I'm studying it and something.
yeah, what?
I'm looking through to familiarize myself with it because I went like my network misbehaved, so I'm trying to study the pattern and see what's going.
Familiarize yourself very well because you answered the last. You answered
Okay.
this one. Okay, so guys, we're going to do another one. These say we recorded temperatures, right? For somebody who do this last one.
Oh, madam, let me try this one.
Ish, let's go. That's how I like
Madam,
it.
me is for my good. Oh, relax. Madam, be calming down. Let's write high as in H-I-G-H.
H-I-G-H. Okay.
Assign it age, temperatures. Temps, I mean, yes, ma'am. So if the temperature, madam, at this point, hot days, that means greater than 30. So, yes, madam, so greater than 30.
That's it. That's it. Oh,
That's
it's simple and
then,
mm-hmm.
madam, then Nusinya will print it. Have you seen?
You want to print
Then,
that? Print high?
yes.
Okay.
Yes, so print high, and then when you're done, then you come back and now we want to check how many high temperatures we have in the list, in the
You want to
NP
count them?
array. Yes, please.
Okay, let's do that.
So you use the sum. So print into brackets.
Hmm?
Madam, is it sum? NP sum, NP dot sum. Sorry.
You got it.
Then bracket open again. Then
Mm-hmm.
your variable, that is TMPS. HIGH or
Mm.
mm-hmm.
I think we don't know. When we see. Okay. In bracket close, right?
Yes, please. So please just
So three
yes,
temperatures
yes,
are about 33 temperatures
30.
are high. Okay, now let's
Yes.
do the filter.
Uh-huh. Madam, please print
Hmm.
then temps,
Tim.
then macho bracket,
What?
then macho bracket. Madam,
Hey,
the square bracket. Madam, please, I'm sorry. Madam, I'm sorry. Then you put
I like it though. Macho bracket
a
thingy.
high, yes. Then you close it with the soft bracket. Then
Okay.
uh yes.
See, that's all. That's it. That's it. Thank you, Angie. Somebody's
Thank
the
you.
last one first. That means people understand. Oh, that's nice. Ah, sweet, sweet. Ah, you pass smart. That's nice. That's nice. That's nice. Who is next? Who is next? Who is hiding? I've not seen him today. I need a guy. Someone, do you think you're ready? What's his name? Bernard, do you think you're ready to take this one first? You think you can? I think you can. I think you can, Bernard. I think you can. Yeah, I think you can do it. So let's go. Bernard. Hey.
Hello.
Yes.
I just even started working on it.
Oh, okay, okay. So you
Yeah.
want someone else to save you. Okay, please,
I'm,
which
I'm,
guy
I'm coming.
will
So
oh okay,
so
let's do it.
let's do high sales.
What?
So write high sale, high hyphen
High
sales
sales. Oh, okay. High sales. Oh, okay.
equal to sales
Mm-hmm. Mm-hmm.
greater than 100.
Greater than 100.
Can you hear me?
Yes. Mm-hmm.
Yeah, into brackets.
Mm-hmm.
Now you print um um I'm coming on.
Are you filtering? She decided
So
to
you
add the
print
sum for us. So this is sum, this is filter. I mean, before you come and copy. Sum, filter.
come here.
Eh, this count, sorry. Count and filter. Count. Mhm. So what's next? Which one do you want to do? Do you want to count or do you want to filter? Or do you want to do both?
Let's count.
Let's count. Okay. We are waiting for your command.
Okay. Um I'm coming on. I'm looking
Let me
through
print this
something.
for you, okay? Let me print this one for you first. So this is what we have, right? We said one, true is one, zero is false, true is one, zero is false, true is one, right? So we want to count it. How do we count? By summing up the ones that are one. Okay. So that's where your MP sum comes in. Because if this, I think you missed that because you were not here. I think you
Yeah,
missed that.
yeah, yeah.
Yeah.
I was gone for like 20 minutes, cry.
Oh, that's crazy. Sorry. I think if you even try fast, we've tried. So let me show you. Let me explain this, okay, to you. And to those who don't get it but are hiding. So if we when we print high sales, you see we get true, false, true, false, true, false. In Python, true is 1. So, Bernard, true is 1. You know this. True is 1, false is 0.
Yeah.
So these are true, false, true, false, true, false. It's basically 1, 0, 1, 0, 1. Yes, 1, 0, 1, 0, 1. Right? So
Yeah.
if I want to count those that are true, those that are the cells above 100, you have to count those are true, right? And
Yeah.
you can do this with a loop or whatever, but with this, because true is 1 and false is 0, if we add them, if we add all of this, it's going to give us it's going to add the ones that are true. Do you believe that?
Yeah.
Yes. So it's going to add the ones that are true. We have only 3 that are true. So 1 plus 0 is what? 1. 1 plus 1 is 2. 1 plus 2 plus 1 is 0. And then 2 plus 1 gives us what? 3.
3. Yeah.
This is the mechanics behind it. Okay.
Yeah.
Let me not do that. This is the mechanics that's going on within this NP sum. Okay, so we call NP summing here. We'll sum up these ones, and when we print it, we have our output here as what? 3. So that's how to count it. See, you have this list is looking like, oh, but madam, we can just count it because it's Kakrebi. We are working with real life data. You have like 10,000. I mean, 100,000. See, 200,000.
Okay.
In here, so you can't count one by one. In that case, you need your NP sum to just tell you, oh, how many people, how many sales did we get above 100? Then you can use your NP sum to do that. Okay, so this filter, and I've gone over it because it's very important. You will use it.
Yeah.
Not just only for our NumPy, you will use it when you get to pandas. You will use it, you will be using it, you will come across it, you will use it. In fact, you will use it. Counting these booleans, you're gonna use it a lot. That's why I am hammering on this side. Okay, so I'm glad you get it now.
Okay, I get it. Thank you.
Okay, Sally. Okay, there's God. So yes, we ran that, and then we are going to continue the filtering. Please continue the filtering for us. Why? Or do you want me to do that for us? I'm talking to Bernard. Please, who will do the filtering on behalf of Bernard? I should just do it. Who do it? Who do the filtering? Eh,
Okay, let me do it.
Mystic.
Okay, so do the print.
No,
Okay.
I didn't witness all those parts. I was
Oh,
going completely.
oh
Yeah.
wow. Then you will have to go back to this recording and listen, okay? Because
Yeah. Okay.
you have a lot to cover, okay? But I hope you can watch what we are doing here. So Lucy, let's go.
Then you have sales.
The sales. As the one we are trying to filter from.
Yeah,
Okay.
then we have the square bracket, then high sales.
Macho bracket. No, hide.
Yeah, macho. Use it as the less words. Macho bracket.
And
And
then
then the soft one. Then you print. Hey, then you.
macho and soft. Yeah,
And that's what she said.
okay. So we go, so we have our output here. Now we see the ones above 100. Okay. Guys, are we okay? I need to see thumbs up from everybody. Everybody. If you're okay, tell me you're okay. If you're not okay, you're going to Lucy to the rescue. Nice, 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 nice. Hey, I didn't see some thumbs up from some people. Who. Shirley, are you here? Did you give me thumbs up?
Yes, I give a thumbs up.
Okay. Okay. Akofa. Yes. I don't really mention your name like that. I don't really mention your name like that. Okay, nice. So this is our example here. Okay. A. Ebefa why? So this is our example. We have this NumPy array with our scores in here, okay? Okay, and then we want to get only the scores above 70. Right? How do we get only the scores above 70? It's already been answered here. But yes, scores, yes, okay, so this filtering was done straightforward. Let me do the breakdown. Okay. Yes, we want to get the scores about 70. So we do a scores greater than or equal to 70. This is our filter, our Boolean returner. Then in here, we're gonna assign it to what? The variable hi, no. No, not past. Let's assign it to the whew. Oh, past, Charlie, past. Okay, we're assigning to the variable what? Past. Okay. Now this is our filter. Now we want to then we go with our scores here. We put our filter here. Go there. Macro bracket, and we have this here. So should we print it? Let me just put an asterisk on this. It's the same thing, right? It's just that it's done in one line. Okay, so pass here, print out, print pass, scores. What's this? All scores here, and then those that passed are here. So what this person has done here, I'm sure if you look at it, you can get it. What has happened what went on here is they did not assign it to any variable, right? You know that this is the same as this. So if you copy this here and you put it here, it will still work, right? So that's basically what the person has done here. Here, and they've assigned it to the variable with high scores. Okay. Do we get this example? Do we get it? Hey, it's the same thing. Oh, we've not gone to a different topic. It's the same thing.
We'll do the first one.
Yes, do the first one. Do the first one. As you progress, maybe you want to shorten it. Okay, so please do this, do it like this. Okay, we're going to the next one. Who will do this for us? Who's gonna do this for us? Break it down for us. Hey. Hey, you not do this one. If I leave you to come and do this one, see as the numbers are playing, you'll be panicking and things here. Okay. I'm gonna take us through it, okay? So we're getting those who failed, right? So we're gonna call it what? Failed. Failed equals scores less than 50. Okay, put that in a soft bracket. Go down here. Then we want to find those that would fail. So we have our scores outside, our square bracket, filled inside, in here, be there, and then print. Okay, so we filtered for those that failed, those that got below 50, and then they are here. If you want to count them, you go np.sum of your Boolean generator. Okay. Then we get that 3 people failed, and these are those sports that failed. Okay. We have our next example. It's just zeros. And it's just zeros. It's nothing complex. Okay. So what happened here? Filter sales only show months with sales above this. Okay. So with this one, so I did this so that we can break down what's going on within this folly, right? With this one, we are just doing our normal filtering, right? But this time we don't want to show the sales, the amounts, the money, right? We don't just want to show the figures. We want to show the months and the figures, and that's why this for loop is here. Okay, so what we're actually working on is this one. Okay, so please don't complicate it in your mind. Let me even wipe this thing here from here. You have it in your notebooks, right? When I finish, I'll undo it and let me look at it. Okay, so we want to show only months with sales above 1 million naira. Okay. So we're gonna call that sales above 1 million naira. We're gonna call that high. I mean, they use high sales. We're gonna call that high sales. High sales equals monthly sale, which is above 1 million naira. Put that in bracket. So this is it. To print high sales, you know what it's going to give us, right? So we want to filter for those ones. So we go monthly sales. Then we have our high sales in here. We're going to go print. Okay. So these are sales, sales above 1 million naira. So undo. Wait, should not shift. Okay, so this is how the question comes, right? And then yeah, so this month here, right? We're going to look through these. This for I in range, not teaching for loops today. That's why I wanted to wipe this. Please don't come and confuse yourselves. I'm just adding this, right? Because it came with the example, right? For I in range, range learn months, right? It creates index for each of these months. Yeah. So this is 0, this is 1, this is 2, this is 3, 4, 5, 6 till 11, because we end at December, right? Okay. So for each element in the range, for each element in the list of indexes for the month, right? Look through each index, right? And then get this I here represents the index, right? So say for index 0, right? You return month 0, right? What's month 0? Month with index 0. For index 1, you return month with index 1, right? So that'll be February, whatever. And yeah, we just wanted to print out the months, right? Okay. Please don't confuse yourself. The main thing that we did with this is this. This is what we did. Inani. This is it. Okay. right? When you go, you can go and break this thing down and try to understand it yourself, this for loop, right? Because, yeah. Hey, what time? We have, please, we get it. We are moving on. I don't know if we have enough time to introduce another concept before this break, but we're going to try. Can we move on from filtering, arrays, and Boolean indexing? Yeah, cool. Okay, we are going. So we have conditional selection with mp.where. Oh God, have mercy. Please, I'm not teaching loops here. I'm not teaching for loops and all of those things here. Okay, I didn't want this confusion. Yeah, I'm not teaching for loops here. So please, if this is what you want me to explain, go and figure that one out yourself because you've already learned for loops. So you can ask ChatGPT to break this thing down for you, right? We are teaching filtering, okay? So this is what the code does. I'm going to go through example 3 again. And then, yeah. Okay, so we have our monthly sales here, and then this is not part. This is our months because this example, the person that said this example didn't want us to just return the figures. He wanted to return the corresponding months. And so that's what this for loop does. This for loop just it creates index for the months, right? And then it will look through each month, and then it will print out look through each index and then get the position of the month, and it will print out its corresponding like month and its corresponding value, right? This is what this for loop does. You can copy it, ask ChatGPT explain this to me, right? If this is where your confusion is, ask ChatGPT, right, to explain this because you've already treated for loops. Okay, we are focused on filtering Boolean indexing right now. Okay.
Please let me take off the internet.
Sorry?
Jesus.
Are you saying something? Okay. Okay. So we have our monthly sales here. This is our array. Okay. And then we are trying to filter for sales above 1 million, right? Okay. So how do we do this? We start with our comparison operator, right? Then we do our monthly sales, which is the array. For sales greater than 1 million, this is 1 million. 1, 2, 3, 4, 5, 6. Yes, greater than 1 million, right? We assign that to the variable high sales. Should we print high sales? We will have our, that means this will be the last example before we go for break. When we print high sales, we will have when we print high sales, we'll have everything that's right. Print high sales, and we have those for each value here. It takes this, compares it to this. It's 850,000 greater than 1 million. No, so it will return false. This is 1.2 million is going to return true. This is 950,000 is going to return false, and so on and so forth, right? With these. Okay. And then we have our filter here. Now we want to use it to filter for those that filter just to show those that are above 1 million. Okay. So we have our monthly sales here. This is what I did here. Our monthly sales here. And then inside of our square brackets, we put what we are using to filter our array of booleans in here. And then brackets close, run it. And then we have our true, false, true, false, true. Wait, we have our, can you come here? See, okay. And then we have the values that are greater than 1 million. Okay. Again, this for loop was just to print. Let me remove this thing from there. This for loop is just to print the months and not just the figures. Okay. So that's what this for loop does. They've created a list of months here, and then this for loop will loop through it and then print they'll look through it and then use this high sales thing here, this high sales filter here, right? Prints the months that satisfy this condition, right? This is the months that satisfy this condition here, that return true for this condition here. And then that's what we have here. So that's what this for loop does. Okay. If that's where your confusion lies, like I said, you can let ChatGPT break. I did that breakdown here because I had a feeling this question might come up, but yeah. It's time for break. Please don't ask me this. Do you get it? Nice. Okay. So I'm gonna go over example 3 again before we go. Okay. So I said that this is your array, right? This is our array, which has a list, which accepts. We have passed a list of monthly sales, right, to this. Okay, so monthly sales contains our array with these figures. Okay, all right. And then we have this list. It's a list of months. Okay. And then our duty here is to filter sales data only to show months with sales above 1 million, right? Okay. So first, we're going to create the filter that will show the sales above 1 million. And how do we do that? We said we do our monthly sales above 1 million. Okay, and then we assign it to this variable high sales. So when we print high sales, we have our Boolean, our array of Booleans, which come from the comparison of each figure here to this 1 million. So if any figure here is greater than 1 million, is going to return true. And if it's less than 1 million, it's going to return what? False. You know this. Okay. So this is our monthly sales here, and then we print high. So we see we are filtering for the sales above 1 million here, and then we have our output here. Right. So all of these satisfied true and printed out true for us. Okay. This is what print high sales. I just wanted to look at the Boolean of this. Okay. So let's wipe this one. Okay. And then we come to this here, right? So the purpose of this code is, this list comprehension is, it's supposed to, so we'll go through each month, right? And it will check whether it will check this mask here, this high month mask here, and it will decide whether or not we keep that month or not. So all the values within this, in this high, it's not high mask at this point. What is it called? Let me make it the original. Okay. This is what we saved our thing. Okay, this is what our booleans are saved to. High month mask. Okay, yes. So this is our filter, right? And then we filter for the results. We filter for the figures that are above 1 million here, and we've assigned them to the value high sales. Okay, so when we print high sales, we'll get those figures, right? And that, which one was never closed? Still not the original, is it? Okay. Okay, so our high mask here, right? This is our filter. Okay, so we've applied this filter on our monthly sales and we've assigned the values, the figures that we get to high sales. Okay, that's what this does. And now we have this month here, right? This month is a list containing our months. Okay, so this question here, the task is to print the months that shows sales above 100,000. So we are not printing just the sales above 100,000. We are actually printing the months with sales above 100,000. And how we are doing this is we have this list called, hold on. We have this list called months. Hold on, let me. Sorry, I'm back. Yes. So we have our list called months, right? And we intend to print or show the months which satisfy our filter, basically. Okay. So the months which have sales above 100,000. Okay. So we start here. Let's break this thing down, right? You guys did list comprehensions last week. Okay. Yes, it's a short way to write our loops. You guys did that with Mr. Victor last week. Okay, so we first start with this, right? This range learn months. I said that this creates an index for the month list. So for each object here, this creates an index, right? So this would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, 11, right? Okay. That is what this range learn months does. Okay. So then we have our for loop here, right? So for I in range month, this will loop through the positions. This will loop through each month, right? And then we'll check one by one. Okay. So I don't want to confuse you guys, okay? Right? But yes. So it will look through and then check one by one, right? For each month, right? And then this month I says when you get to my index, like index 0 here, month 0 here, give me the month, the position here, right? And then we have this if statement here, right? Which is checking the filter here, our filter that we've created here, to filter for our months greater than our sales greater than 100,000. Okay, so if we have what is our true false here? We didn't print that. Okay, so if it returns true, it's telling Python keep it, right? If it returns false, it's telling Python ignore it. Just keep those that returns true for this. So what this whole thing does is that go through every month, right? Go through every month here, right? And then keep those for which this mask is true. Okay, so we are comparing the index. So this index position, if you index 0, right? High max 0, month 0, right? So this first one, we are checking this first one. 0, this is index position 0, right? Month 0 is what? January, okay? So when you come here, check this one. Does it satisfy this? Does it print true? Does it print false? If it prints false, ignore it. If it prints true, like this one, return its month counterpart. Okay, this is max 1. If max index position 1 returns true, return month index position 1. Basically, that's just what this says. Okay, so like I said, if you need further breakdowns for this particular line, please go and ask them. You can, yeah, ask ChatGPT to break it down for you, and then you get it. But I hope you guys get it. Okay, I'm not the best at explaining list comprehensions, but yeah, that's what we have. So please, we are moving on to our next topic. We're supposed to finish this during our first class, our first session, but I guess that did not happen. So we are moving on. Okay, please, shall we? Thank you. Also, something that was shared with me was that you guys can, you guys can meet up and then like decide to put yourself in groups and then meet like after classes, maybe at night, and then you guys explain things among each other. Do the peer-to-peer learning. Like if you have something you don't understand, you can just bring it up to someone who is good at it, and then he or she just explains to the entire group. You can choose to do that. You can choose to organize yourself, put yourselves in groups. You're not even many, so all of you can even be in one group, and then you can maybe pick a leader today to explain something. Someone's going to explain something the next time, and next time, and next time. So the peer-to-peer learning can go on also. In the case where you don't understand list comprehensions, you don't understand for loops, you don't understand anything, you can bring it up to them. If you're not comfortable bringing it to us, you can also bring it to either me or Mr. Victor, and then we're going to explain it to you. But I feel like peer-to-peer learning works really, really well. So you guys can consider that. Okay. Yeah. So we're going to go to our conditional selection with NP where. What is NP where? You might not have this, but yeah, I did mine like this. So this NP where, it applies a condition to every element in an array. So this is the syntax, right? You have your NP where outside, then your condition, it's kind of like an if statement, right? Your condition if true, your condition, sorry, then your value if true, and then your value if false. Okay, so let's look at our example here. Okay, so it makes sense. So we have scores here, which is our NumPy array containing these scores, right? And then what's the first thing we want to do? We want to label each score as pass or fail. So our syntax goes NP dot where. What's our condition? Okay, this question is kind of incomplete, right? So what we are doing here is if the score is above 60 or above, it's pass. If it's below 60, it is a fail. Okay. Okay, so if it's pass, it's above 60, if it fails above. So what's our condition? What's the syntax? Syntax here is NP where condition and then value is true and then value is false. So what's our condition? We're trying to find out if it's above, if our score is above 60, print pass. If our score is below 60, print fail. Okay, so we're gonna start our condition. What's our condition? If scores, this is doing it without the if statement. Okay, see, NumPy, it's flexible like that. So we have scores. If your score is above or equal to the pass mark of 60, 60, print what? Pass. Else, print fill, but you don't write the else, right? Print fill, bracket close. So in this case, what will happen here is each element of your array will go through this, right? So if 72 is greater than or equal to 60, it will print pass. If it's below 60, it's going to print fill. Okay. So we go here. It's 45 greater than or equal to 60 is going to print what? Fail, because 45 is less than 60. It's 85, 88, like that. It's going to go through here. 88 is greater. It's going to print pass. 55 is not greater. It's going to print fail. 91 pass. 66 pass. 48 fail. 76 pass. 84 pass. 30 pass. 38 fail. Okay. So so this has been done. Yeah. This is okay. So we've here our result has been equated to the variable labels. Okay, so that's how this was come about. Yeah. Should we print our label? I don't like all these talks. Print our labels, and we'll have our pass, fail, pass, fail, pass, fail, pass, fail, pass, fail. Okay. It's just like straightforward like that. Okay. It's like an if statement. If the score is greater than 60, print pass, else fail. That's just what this line is. Okay. So we are kind of doing our if statement within our NumPy. Okay. And then we use np.where. Okay. Do you understand what I just did? Should I take it again? I can, if you need me to. Did you understand what I just did? Nobody gets it? Okay, we're gonna take it again. Okay.
Madam, please. The NP where has the condition value if true and value if false.
Yes.
Is that it?
Yes.
So you're saying that instead of the loop, this one is making it simpler. Okay.
Instead of the if else statement, this is making it simpler, because if, say we're writing an if else statement for this, right? It would be if scores greater than this, print pass, Abby. Else print fail. Which is much longer, is it not? Much, yeah. So this kind of like condenses that. It makes it simpler, in my opinion. I feel like this is simpler because we have your condition first, your value if true, and your value is if false. Okay, you can do, I'm gonna put on a hash here. You can do so yeah, so whatever your condition is here, and whatever you want to print when the condition is satisfied, and what you want to print if the condition is not satisfied, that's just what this syntax is about. Okay. Let me see. Are there more examples?
Okay.
Victor?
I just wanted to add to what you
Okay.
just said. So just think of it like this, right? Let's say that you have a list of numbers, right? You have a list that contains 72, 48, 30, I say 48, sorry, 45, 88, 55, and other numbers like that, right? So what you want to do is for each of these numbers happens to be like a score for different students. So your focus is on, okay, so let's see those students who get above 6, which is like the cutoff value itself. You know, the way you will go about it is because it's a list, you will say, oh, let's use the for loop for I in this. If the value is greater than this, please give pass or please give fail, right? So maybe what you want to do is for those scores that are above 60, we give the word pass. For those that are below 60, we give the word fail. So that will mean that, once you use a for loop, you create another empty list just so that you can append. So if for those people who get above 60, you see pass, right, as like the word representing the value itself. For those who score below 60, you see fail as the word representing the value itself. But now, instead of using the for loop, because if you think about it, you're using the for loop, you're also using the if else statement. So it's like for loop and if else statement for implementing something like that, which is where the NumPy comes. This is why NumPy is really fast, right? So with the NP dot where it's like saying, okay, you know what? I have a condition, and the condition is I'm just concerned about values that are greater than 60. So any value that is greater than 60, I am meant to give the word pass. So, if, for example, I see a value like 70 or I see a value like 68, it's most likely going to be passed, right? So with the NP dots here, you're applying that. So it's like you're doing a loop, right? So you're applying that particular condition to each items in this stuff itself. But now take notes, this is not a NumPy array, right? Because, we can see this like np dot array. So it means it's not a NumPy array. So instead of using a for loop, now you're using NP dot here. So it means that NP dot, what it does is it applies the condition to all the items in that array. So what is the condition? So the condition is cost has to be greater than or equal to 6. So the question is, when you say, okay, now that you've assigned a condition, there has to be an output. The output for if, the output for else. So it means if the condition is satisfied rather, you give pass. So it means if the cost is greater than or equal to 60, pass. Else, give fail. Because instead of using the if else instead of using the for loop, the if else statement, now you're using NP dot here, which makes it very easy. Because if you're going to write it in the for loop, right, what you would have done is for scoring scores, colon, then you now say if score is greater than or equals to 16, colon. Then the empty list will be empty list dot append score. Dot append pass. Else, empty list dot append fail. You can see, that will mean maybe like 5 lines of code. But now you're using the NP dot where. So what you're doing is NP dot where. Okay. So where what? So you're passing in the condition. What is the condition? The condition is cost as greater than 60. Okay. Now, if there's a condition that cost greater than 60, it means you're gonna have 2 outcomes. Either you give this or you give this. What are the 2 outcomes? So if that condition is met, that's cost greater than 60, please give pass. Else give fail. So you can see for all the items like that, this particular condition is outside. So the first time it checks 72. Is 72 greater than or equal to 60? Yes. So assign pass to it. Note the next value, 45. Oh, 45 is not, it does not meet this requirement. So it gives fit to it. I don't know if this further just adds to what KJ is trying to say.
Thank
Can I
you
give a
so
thumbs
much.
up?
Thank
Okay.
Please,
you.
do you understand what Mr. Victor just explained? So it just saves you the stress from, oh, nice, nice, nice. It just saves you the stress of writing multiple lines of code, okay? In that. Thank you, thank you, thank you. Okay, since we all understand. I want to take another example. But there's no more example. Okay, aha. This one is here. So what's our syntax again? Let me bring it here. We are looking at this one. I don't think you have this in your notebook, but yeah. Okay, so what's our task? Label, pass. I know the same thing. Label, pass. If the score is above 60, equal to 60 or above 60, or label fail if it is not. Okay, so our condition is going to start here. We're going to start with our np dot what where. Then inside of it, it accepts our condition. What's our condition is if score, it will scores above or equal to 60, then what? Return pass. Or otherwise, or else, return fail. Brackets closed. We're gonna assign it to results. And we print results, we see A, C, B, and then we have that because 40, so it goes like this, 40, it will bring 40 here. Is 40 greater than or equal to 60? No, so it's going to return what? Fail for that. That's how we have fail here. Is 65 greater than or equal to 60? If 65 is greater than 6, it's going to return pass. 78 is going to return pass because it's greater. 50 is going to return fail because it's less. 90 is going to return what? Pass because it's greater. That is it. I guess it's the same example, same kind of example. Okay, so let's look at this one too. Okay, so we have, they said that you should return hot if it is greater than 30, if the temperature is greater than 30, or else return normal if it's not. Okay, so we have our array of temperatures here. We start with our what? NP where. And then in there we have temps. What's our condition? If the temperature is greater than 30, please return hot. Otherwise, return normal. We didn't print that, but yeah, we have our results here. Normal, because 25 is less than 30, 32 is greater, so we have what? Hot. 18 is less, we have normal. 29 is less, we have normal. 35 is greater, we have hot. So all the higher temperatures, all the temperatures greater than 30 are going to return hot. Let me do our print here. Okay. Please, we understand this. Hey, you don't mind me. Honestly, yes, it does. It works almost like lambda. Yes, it does. Yes, it does. Okay. Because lambda, we treated something like this within that. Okay. So we have our next example here. If the salary is greater than 10,000, add 10%, else no change. I think there was a first example here like that. So let's look at that one before we come here. Okay. Okay. Then we can go to the nested ones. Okay. I just wanna. Okay. Or should we do, let's do the nested ones first. Okay. Okay. So we have what we call nested NP where statements for multiple conditions. Okay. So in this case, yeah, we have our scores here. These were our scores. And then we want to return for scores above 80, we want to return. You remember grading, how you were graded in school, right? If your score is above 80, you want to return A. If it's above 70 but below 80, we want to return B. If it's above 60 but below 70, we're going to return C. If it's above it's above 50 but below 60, we're going to return D. Else F. Okay, let me show you how this is constructed. This has been put in different lines, but it's just, let's start with the construction here. right? So we have our NP dot where. And what are we first looking at? If the score is above 80, we want to return A. So that's our first one, right? So we go scores above A, greater than, equal to 80, return what? A. And you remember that within our, let me bring the syntax here. Remember that with our syntax here, we have our condition first, then your value if true, then your value if false, right? So we are saying that if the score is above 80, return A. If it's not above 80, then another NP where comes. That's where that's what we call a nested NP where. It's an NP where inside of another NP where. So this one we are nesting multiple NP wheres inside of them. Okay. So it says if this condition is true, print A, else check again, right? Else we have NP where again. Then we have our scores again. Else if it's above 70 or equal to 70, above or equal to 70, return B. So now we come to this NP right here. We are looking at this condition. Our condition here, our value if true. If it's above 70, return B. Else, then we go to another one again. Okay. So basically, those that don't, if it's gonna start like this, it will take 72 here, this 72 here, it will pass to here. Is 72 above 80? No. It's below 80. So it will not work. This condition will not run, right? This is what's going to run. Whatever comes after this is going to run. So it goes here. It's NP where it's the 72, which is the score here, above 70. If yes, it will return what B. Because it is yes, it will end here for 72. Then the next one will come. This 45 will go through it. So we're going to continue building our nested NP where, okay? So we first started with this. This is our first statement. If this condition is above 80, above or equal to 80, return A, okay? Else, if the condition is above or equal to 70, return B. Else, then we have another NP where within it. Else, if the score is above 60, above or equal to 60, what's our condition if true? Return C. Else, so our condition if false, right? Then we have another NP where in there. NP dot where. So this is our false condition. Else go here again, meaning if it keeps going, it means it doesn't satisfy this condition. We have something like 45. It goes here. Does 45 satisfy this condition to get a no? So it goes to the next one. Does 45 satisfy this condition to get B? It says it goes no. So it goes to the next one. So false, it goes to the next one. That's 45. Is 45 greater than or equal to 60? No. So you go to what's the next one, right? So we have our NP where. Then if the score is above what? Above or equal to 50. What is our value if true? Return D, right? D is our value if true. Else, return F for the rest of the conditions. So if the condition does not satisfy it, return return F. I'm going to go over it. Okay, so now this is the full length of it. And because of all of these brackets here, we need to add our brackets here so we can close it. So we have close this one, close that one, close the main one. Okay, so this is what our nested NP word is. Okay, so we have 72 here as the first element scores. First score here, it will go through here. Is 72 above or equal to 80? No. So it will go to the condition if false. These are all the conditions if false after this. Right? So then it will check. Is 72 above or equal to 70? Yes, 72 is above or equal to 72 to end here. Then to print out our B. Then goes to the next one. 45. Is 45 above or equal to 80? No. So what will it print? Value, it will go to what value if false, right? Then value if false, we come here. It's 45 above or equal to 70. Our condition if true will not be settled, so we go to what? Condition if false. So within this one, these are our conditions if false. Okay. Hey, our value if false, Charlie. Our value if false, right? Okay. So now we take 45 again. Is 45 greater than or equal to 60? No. So this we can't print C. So we have to go to our value if what? False. Then it comes here. Is 45 greater than or equal to 50? Again, we can't print the value if true. So we go to what? Value if false. And we end on our what? If. So it will go through this, it will be applied to every element in here. 88, we have 88, put it here. Is 88 greater than or equal to 80? Yes, it is greater than 80. So it will end here to print the value if true. It won't need to go through the list of values if false, right? And settle any of them. This has made it, so it will just print A. We have 55, it will go through here. Is 55 greater than or equal to 80? It's not going to print A because it's not greater than or equal to 80. Now it comes to our value if false. Is 55 greater than or equal to 70? It's not. So it moves to the value if what? False. A moves to the value if false, which is here. Is 55 greater than or equal to 60? No. So we can't print out the value if true. So we move to what? The value if false. Is 55 greater than or equal to 50? Yes. So we will print what? The value if true here. Then we have our D for 55. And so on and so forth. And so on and so forth. Please, do you understand? This is the same. This line is the same as this. It's the same thing. Only two people understand. Ew. Okay. Should I take it again? Or Mr. Victor, can you say this in like maybe add your voice and let's see if it makes a difference. Of course, also make a difference. But let's can you please, yeah.
Okay, no problem. So now if you look at the question, what you're trying to do is you're trying to assign a grade to the different scores, right? So what are the grades? The grades are grade A, grade B, grade C, grade D, and grade F, right? Remember, this time we're not using for loop. You know, if it was to use for loop, we're just using for, then if, else if, that kind of thing. Well, you're just using np dot where. So for the first time, we check, okay, so np dot where. What is the condition? The condition is for you to get grade A, right? The score has to be at least 80, which means score has to be greater than or equal to 80. So if that's the case, you will get A, right? But if that's not the case, remember that we have other grades. There's grade B, there's grade C, there's grade D, there's grade F. So it means that the first condition is if you get a score that is above 80, greater than or equals to 80, we will say, okay, fine, you get grade A, right? But if that's not the case, it means we need to check again what's your score, which is why you need to have np.where again. So we'll check np.where. So if we check again and we realize that the scores is greater than or equals to 70, what that means is you're going to get grade B. But Victor, if that's not the case, it means we need to check again, which is where you have np.where again. Remember, it's nested. Let me take that again. np.where for the first time, you're checking if scores is greater than or equals to 80. If that's the case, remember I said np.where get to outcome, whether it is this outcome or this other outcome, right? Now, so what's the outcome? If the score is greater than or equals to 80, we'll say obviously that student got grade A. But if that's not the case, it means we need to check your score again to be sure, because we already said if you get above 80, it means you get grade A. What if that's not the case? What will the person get? It means we need to check it, which is why we said, okay, you know what? For the second option, it means we have to check it again. And how do we check? Which is why we said np.where, then you check. So if the score is greater than or equals to 70, it means we give you grade B. It means that the person got grade B, right? Which is why you can see grade B. So if that's not the case, it means we need to check again, which is why you see another np.where again. So you are checking because the first time we checked, if it's greater than or equals to 80, it means you get grade A. If that's not the case, it means you need to check again, which is why you add np.where, you check. So if the score is greater than or equals to 70, it means you get grade B. Victor, if that's not the case, obviously we need to check again, which is why we have np.where again, right? So we check. So if the score is greater than or equals to 60, what do you give the person? Grade C. But Victor, if that's not the case, it means we need to check again. Remember, we have A, B, C, D, and F. So we check again. Okay, so np.where scores is greater than or equals to 50. It means give the person D. So if that's not the case, it means give the person F, because F is the last grade. If it was A, B, C, D, E, F, for example, after that MP dot, so after you checked for D, would have needed to check again for E, right? But because it's just A, B, C, D, then F, you can see F is the last one, which is why we said MP dots where once scores is greater than or equals to 50, give D, else, what's the last grade? The last grade is F. Then you just write F. So if you notice, how many open bracket do you have? You have 4 open brackets. So that means that you're going to provide 4 closing brackets, which is why you can see you have the first closing bracket, second closing bracket, third closing bracket, and fourth closing bracket. So let me just say this. So imagine we had A, B, C, D, E, F. A, B, C, D, E, F. My question is, how many NP dots where do you think we are going to have? You can just drop your answers in the chat. If we had A, B, you can see here is A, B, C, D, F. Imagine it was grade A, B, C, D, E, F. That's 6. So my question is, how many NP dots where do you think we are going to have? Just drop the answers in the chat. Please drop your answers in the chat. If you still do not understand, let us know so that we can take that again. We need more response. Please. Just 2 persons. We need more response. Please. So the question is, okay, imagine the grade we are assigning is grade A, grade B, grade C, grade D, grade E, and grade F. That's 6 grades. So my question is, how many NP dots where do you think we are going to have? That's my question. Because here is just A, B, C, D, F, which means you had 4 NP dots where. So I was saying, imagine you had 6 grades. How many NP dots where do you think you're going to have? Please, we need more response in the chat. 5. Yes. So correct. Okay. I think they understand. So if you understand, please just give me a thumbs up so that we know that you understand the explanation, please. Okay. So I think Kezia, please.
Thank you. So guys, that's
Hey,
it.
Victor, did you say the grades was just up to E or up to F?
It's up to
So
F.
I was saying up to F, A, B, C, D, E, F. That's what I meant.
Okay.
Yeah. Here is just 5 grades, A, B, C, D, F. So that's 4 NP dots where. If you add 6 grades, that would mean 5 NP dots where. That's the question I asked.
Right. Okay.
Okay. Okay, guys. Ew. Okay. Okay. So this for loop just You know what this for loop does? It just prints the score with its grade assigned to it. Okay, that's it here. Thank you so much, Victor. Okay, guys, since you get it, we are looking at our next example. Okay, so we have apply a discount to expensive items only. Okay. Okay, so we first have to define what are expensive items, right? Okay, so that will be our condition. Bring the syntax again. Here. Okay. 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 So we're gonna build it. Okay. So they said that we need to apply a discount to expensive items only. Okay. So what is the expensive item? Items greater than 1,000 naira. Okay. How much is 1,000 naira in cedis? I don't know. Items greater than 1,000 naira are expensive items. Okay. So we're gonna start with the condition for that, right? We have prices. Hey. Prices greater than 1,000. Okay, so what's the condition? We have to have our NP right here. NP dot where bracket open. Prices greater than 1,000. Value if true. If this condition, if this is greater than 1,000, what's the value if true? Add give a 10% discount to such items. Okay, so in that case, if you are greater than 1,000, how do we do a 10% discount? 10% discount is equal to 90% of the price, right? Okay, so 90% is 0.9 because 90 over 100 gives us 0.9, right? 90 divided by 100 equals 0.9. Oh, I didn't even have to type it. But yeah, 90 divided by 100 equals 0.9, right? So we have that here. So we have our condition. If our price exceeds 1,000 naira, do what to it? Take out 10%, meaning discount the price by 10%. So how do you get 90% of something? By multiplying it. How do you get 90% of something? How do you get a discount, right? By taking that 10% out of 100, we have 90 left, and then we multiply that price by our 90%. Basically, 90% is 90 over 100, which means 0.9. Okay, so our value, if true, would be prices times our 0.9. Here. Else prices. It didn't really state. Okay. I want to print this out. So it's the same here. Just gonna scrap this here. And then, okay. Where's that? Okay, I don't really like this. Okay, so after the discount has been applied. Okay, so let me explain what this put is. Okay, so let's take it again. Okay, we have our condition. If the item is expensive, and what do we consider expensive items? Items greater than 1,000 naira. Okay, so where the item exceeds 1,000 naira, what's the value if true? Multiply those items that's satisfy this condition by 0.9. Else, just return the normal ones. Otherwise, if it doesn't satisfy this condition, just return it. Okay, that's what this prices here does. Okay, so with our list here, we have 500. Is 500 greater than 1,000? No. So it doesn't satisfy this condition. So what's going to happen is going to stay 500 when we print. Okay. We have our 2000 here. Is 2000 greater than 1000? Yes. So if 2000 greater than 1000, what will happen is 2000, 2000 times 0.9 in there. And it will give us the new price, the discounted price, which is what? 1800. Okay. Then we'll take it. Is 150 greater than 1000? No. So 150 will be returned as the normal price. Okay. Same for 3005 is greater than 1000. So we get its discounted value. Okay. And which would be 3150. So this is 10% off. Then we go 800, 800 greater than 1000, like that. If it's not greater, it's going to return the 800 just as it is, untouched. 400, if 4200 is greater, it's going to return its discounted counterpart. 350 is not greater than 1000, so it's going to be returned as it is. 1200 is not greater than 1000, so it's going to be returned as it is. Please, do you understand? Do we get it? Hello. Okay. Do you need me to take it again? Or do you want me to invite Victor? Okay.
He's doing the A. Okay, let me also just add to it.
No,
Okay.
when she said hello, I was replying hi.
Okay. Okay.
Hey, you're making me panic. But Victor, please add your voice.
Okay. So let
When
me
we
let me
hear your
just.
voice, it makes sense to me. Okay.
Okay, so let's look at it from this angle, right? So imagine you have an item that you want to sell, and you want to sell it for 1,000 cedis. So and you say, okay, fine, because you want to attract customers, you decide to do an advertisement that you sell that item for at a discount of 10%. Now, so if you think about it, now 10% discount would mean that instead of me selling that item for 1,000 cedis, I'm going to sell it for 900 cedis because 10% means, if you say 10% discount, it means that I'm selling that item for 90% of the original amount. That's what it means, right? So it means that, okay, if for example, now let me just ask this question. Imagine that same item, I say, okay, you know what, I'm giving a discount of 40%, right? It is 1,000 cedis, but we are giving a discount of 40%. How much do you think that item will be sold for now? Remember, the item cost 1,000 cedis. And we are giving 40% discount. My question is, how much would that item be sold for now? Since I already said 40% discount, how much is it going to be sold for now? Just drop your answers in the chat. The original price is 1,000 cedis, but I decided to give a discount of 40%. Right. So my question is, how much do you think that item will be sold for now? Because, from the explanation I just gave, 10% discount of the item itself would mean that, okay, instead of me selling 1,000 cedis, I'm now selling it for 900 cedis. So if I say, 20% discount, so instead of me selling for 1,000 cedis, I'm selling it for 800 cedis, right? So my question is, if it's like 40% discount, what's like the amount itself? I need a response in the chat, please. I just want to be sure that I really understand this before I continue. Please, I need a response in the chat. So my question is, if you are giving a 40% discount on the price of the item, right? How much are we selling it for? The original price is 1,000 cedis. So, but if you are giving a 40% discount, so how much is the current price of the item? Please drop your answers in the chat. Okay, Melissa said 600. Yeah, 600. Yes, very good, right? 600. That means that 60% times the original amount, right? Which is what we did here. Because it said 10% off. 10% off means 90% of the original amount. That's what it means. So you can see in this case, so our focus is that, okay, you know what? Any price, we sell different items. So you see those items that the price is above 1,000 cedi. In order for us to attract customers, let's just give them like a 10% discount. right? Whereas the other prices, so if an item costs below 1,000 cedis, it means obviously we'll still set up for that same amount. So what we did was, okay, NP dot where. So anywhere you notice that the price of my item is above 1,000 cedis, please, you are giving a discount. So that discount will mean that 90% times the original amount. Remember, the original amount is this price itself. So if I say 10% discount, that means 90% times the price. And you know 90% means 0.9. So what this means is for cases where the price is above 1,000 cedis, please do prices times 0.9, which means give a 10% discount. Else, they can leave this as the normal price. So what this means, there are two scenarios. So it's either the items that I sell, it's either they are above 1,000 cedis or they are not above 1,000 cedis. So if they are above 1,000 cedis, what is the goal? Please give a 10% discount. Else, if the item is not above 1,000 cedis, just leave the price as which is why you can see there are two like outcomes. For cases where the price is greater than 1,000, so it means the amount now would be prices times 0.9. Remember, it's 10% discount. I know 10% discount means 90% of the original amount. I know 90%, that's 90 over 100, means 0.9. So it means 0.9 times the price for cases where the price is above 1,000 cedis. Else, then to just leave the prices like that, which is why you have it like this. So I don't know if this is clear now. You can just give a thumbs up.
Thank you, thank you. Please, is it clear now? Mind us, oh, mind us. Okay. Great, 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 great. Thank you so much. Thank you so much. What's our next example here? We have our last example before we go to combining conditions in NumPy. So we have our salaries here, and we have 5,000, 12,000, 8,000, and 15,000. Okay. And then we say that if the salary is greater than 10,000, add 10%, else leave it as it is. Okay. So we're going to start our condition, NP dot where. First, let's do 10. If you're adding 10%, everything, a whole number is already 100%, right? So if you're adding 10%, what does it become? 110, 110%. 110% is basically what? It becomes what? 1.1, right? Gives us 1.1. Happy. Because 0 cancels 0, and this 0 comes here, comes 1.1. Okay. So this is our, right? So people that earn above 10,000 cedis, they are dashing them. Maybe they are seniors in the office, right? So maybe they get some, what do they, maybe extras on this side, right? Those people that are seniors at the workplace, they get 10%, maybe extra, some money from whatever. So yeah, so we have our salary here, and then we want to change. We're gonna start with our condition, right? NP dot where. What is our condition? If our condition, right? Our condition is if if your salary is greater than 1,000, 10,000, we want to add 10%, right? So if you're adding 10%, it's going to be your salary times 1.1 per this calculation that we did here. You can do this in any way, any mathematical way you want to come about this. This is how I decide to do mine. You can do yours, however, and you can share with us, okay? Salaries times 1.1. Else return what? Salaries as it is, with no change. Okay, so we're gonna call this updated. I'm gonna print that. Okay. So for this, salaries that were below 5,000, they didn't get anything added to them. They were returned as they are. This is 12,000. 12,000 is above 10,000. So if you're adding 10% of 12,000, that would be 1,200. When you add that to it, it's 13,200 here. This as it is here. 8,000 is not above 10,000, so you won't get any 10% added to you. 15,000 is above 10,000. Obviously, 15,000, if we calculate 10% of 15,000, we get 1,500. Added to this will be 1,658. 16,500. And that's how we have it here. You get it? Do we understand? We understand. I know we understand. Give me thumbs up if you understand. So you understand, you're not minding me. Hey, is it fair? Okay. Thank you. Okay. But if you don't get it, please tell me and let us take it again, because we are leaving this, we are moving on to another concept. If you don't understand anything, you need anything to be revisited, kindly tell me now or forever hold your peace. So everyone is okay. Did I see Samuel, Bernard? Samuel, Bernard, Ernest, Chris, Ella, Shirley, Akofa, Melissa, Angela. I know all your names. Lucy, of course. Okay, guys, so we are moving on to combining conditions in NumPy. Wow. I really underestimated this thing. Yeah, I thought we'd finish this in our first period and do today's agenda. But okay. So we have combining conditions in NumPy. So this one is pipe, this pipe here. They will not let me put this here because that's basically the building block for this table here. So pipe, by pipe, I mean this. Okay, they just won't let me put it here. If I put it here, it will give me nothing because this is how you build a table in Markdown. Okay. So this is what I meant by pipe. All right, so in NumPy, we can combine conditions to filter our data more precisely. Okay, and then we do that with our end. This symbol for end. Someone mentioned this symbol. He said it's called absandlant or something like that. Who said that? Like our first week. I don't know. Yeah, I don't remember. Ampersand. Thank you. Ampersand. This is called ampersand. Okay. And this is Lobaligi. Sorry. And this is our pipe. Okay. So this means not. This means, oh God, I'm too childish. And this means pipe. And this means this is ampersand. Okay. So ampersand is for end. Pipe is for all. And this, someone tell me what this Lowaligi is. This Lowaligi is for not. Okay.
Kelly, hey, no, the infinity of
It's infinity. Oh, okay. Lucy is saying it's infinite. Hey, please pronounce it. Tilde or tilde? Tilde? Tilde?
Yeah, like do the operator.
Tilde operator. Thank you. So this is our pipe, our ampersand, and our tilde. Okay. Thank you. We are learning. Okay. So we have our first example here. Okay, so sometimes we want to combine our conditions. Okay, yes, we don't want to just use one condition to filter. We want to combine conditions, and in this case, we're going to use our ampersand, our pipe, and our tilde. Okay, all right. So we have our scores here. I really like logarithm. But we have our scores here as our array of scores. Okay, and this is what we're going to be working with, right? They said important. Use parentheses around each condition. Yes. Okay. All right. So we want to find with this example here, we are trying to find scores between 60 and 80. You know, the first thing we did, we're just looking for when we were filtering, we just had this one condition, just score greater than 60, and we just go like that. No, in this case, we want to find a range. Okay, so how do we find a range? We need to use our ampersand symbol here. So let us start building our thing here. It's already here, but we are building it. Okay, so we are looking for scores between 60 and 80. So we first do the condition for scores between 60 and 80. So we have scores greater than or equal to 60. It could be greater than, but scores greater than or equal to 60. So we first start with that. It has to be in what? Parentheses, brackets. Scores. Good. For score greater than what? 60. This is our first condition. And ampersand. Scores less than 80. Okay. So this will give us the range of scores between 60 and 80 inclusive. Okay. 60 less than 80. So yeah, you see that these are separate conditions here, right? And we are combining the conditions. Right now, we want to find the range, the values between this and this. Between 60 and 80, we have 60, between 60 and 80 inclusive, we have 60, 70, 80, 90, 66, 162, to 80. Okay, yes. So we have our conditions here. And then remember how we do our filtering? Okay. We do our filtering outside of this thing with our macho brackets here. And then we have what scores outside. So with the last one here, let me just do the last one. Say wanted to print for filter for scores greater than 80, right? This is how we're doing it. We'll have our score greater than 80 here. Is how we're doing it. And then we need to assign them to a variable something greater. Let's just call it greater, right? This is how we're doing it. And then we would go scores and then put greater in there, right? And then this would give us our filtering, right? In this case, I also told you guys that if this is the case, this is the same as this. We could just put this here and this erases all in all. Do you understand? Please, you understand that if greater is here as the variable, we could just put this here, put this, the content of the variable in here without even assigning it to a variable. Good. So that's what is going on with this one, right? So wipe. Then, so our first condition here and our second condition here. So this will give us, we'll filter for scores between 60 and 80 inclusive, meaning 60 and 80 are parts of this filtering. Okay, so we want to print it. We can just go ahead and print it, or we can assign it also to a variable. Doesn't matter. And then we have our scores between 60 and 80 from this array. Please, do we get it? Do we get it? Do you understand? So it's basically the filtering that we did. We did filtering and we spent a whole lot of time there. And we are just adding another condition because sometimes you want to filter for a range, right? It's not every time they are just going to filter for 60 going or 70 going. Sometimes you want a range, okay? Sometimes you want everything but what is in the range. That is where the logarithmic tilde will come in, okay? So I'm moving on to the next example with or, okay? So with this example, it says filter for scores below 50 or above 85. In this case, what are we going to use? Our pipe. Yeah. So let's do that. It said was scores below 50. So we're first going to do scores below 50. Scores below 50. Brackets, because the set is very important. Okay. Then what score in the bracket. Can you hear me? Am I audible?
For me,
Nice.
you cut off at a point. So I don't know if it's just me.
Okay, sorry. So I'm going to take this part again. So we are doing scores below 50. And that's what we've put here, one condition, and score above or scores above 80. So score A, above 85, right? Score above 85, okay? And then we're trying to find either this or this, right? We're trying to find the scores above 80 and the scores above the scores below scores below 50, scores below 50 and the scores above 85. Right? We're trying to find the extremes, right? So this is where our pipe comes in. We're trying to find everything on the other side and on each extreme, right? Okay, so we have our or here, which is our pipe. Okay. And then we put our macho brackets here and then come in and do our filtering. To filter, we bring the name of the array here outside of our filter. Okay, equals, what did they name it here? Extremes. That's how we came about this key. Should we print it? It shows scores below 50 and scores above 85. So every score here is either above below 40 or above 85. Any score between these two that is not existent in our list. If we wanted to find between it, we will go with our end, right? Okay. I want to try this. I'm constant. Extreme one. How was it? Okay. All right. Just wipe it. Okay, this is my own thing. Okay. Please, do we get it? Do we get this example? Every value in here is a score above below 50 or a score above 85. Okay. If we want to find a range, we're going to use our end to find a range. But even with that, our symbols are going to have to change, because what is the range of values between values less than 50 and greater than 85? There's nothing like that. I think I tried to use the end that we had an empty list, because which values are less than 50 and greater than 85? Nothing like that exists. Okay. So we're trying to find the extremes. So we use our or so that I can cater for the values below 50 and the values above 85. We're not finding a range. We are finding the extremes. What is outside of the range? Please, you understand? No? Okay. Okay, let's look at the next example. We said this logology means not in. Okay. So we have our range here. We are supposed to find students not in the 60 to 80 range. We first found students in the 60 to 80 range. So let's do that. Let's create the 60 to 80 range, and then we'll use the logology, a tilde to negate that. Okay. So students in the 60 to 80 range, how do we find a range? We're gonna use our end, right? So we have what? Score, brackets, scores, students greater than or not in, so greater than or equal to 60 and greater than or equal to, scores greater than or less than or equal to 80. Right. This would print values between 60 and 80 inclusive. Okay. But if we want to negate that so that we don't print values inside of that range, we can go with our tilde out here. We put everything in the brackets and then go with our tilde out here. So you're telling, hey, yes. So you're telling Python that, hey, look at this range. Give me everything about what is in this range. Okay, so negate this. Give me what is not in this range. Okay, tilde means not in. So give me what is not in this range. Then we go with our macro brackets here. Then we have our scores outside our square brackets, and then we have our scores outside this. Okay, and then we can just print that. So it will print out everything but what exists within this range, within this 60 to 80 range. Okay, between 60 and 80, we have 60, 61, 62, 63, 64 till 80. So give me everything but 60 to 80. Okay, that's what this tilde does. Just negate whatever is out here. So give me what is not in this list. Okay. Please, we understand. Nice. Nice. Can we move on? Hey, okay, we have some examples here. Charlie. Hey. Today. Okay. So we have some examples here. I'll be calling you guys because I can see that this task is approaching your lunchtime. You are getting sluggish in all types of so we gotta do this. Okay, so we have we need to select scores between 30 and 60. I'm gonna do this first example, and then some people are gonna take the rest. People who have not spoken today. Hey, Lucy, in a way you won't sorry, taking yourself out of this. Taking yourself out of this. So I'll not be able to mention Lucy's name. So we're gonna start with our scores between 30 and 60, okay? So scores between 30. We're going to first start with that. Scores between 30 and 60. So scores greater than or equal to, it didn't really state, so we're going to make it like that, greater than or equal to 30. It's a range. So we go and ampersand scores less than or equal to 60. So between was less than equal to what 60 brackets close. This is our filter. So we're gonna call that filter. No, we will not call that anything. We just go ahead and filter straight ahead. Straightforward. Scores outside of our filter here. And then we gotta go just print that. See how we are writing all our code in one line like this without doing any yes. So we have the scores between 30 and 60. 30, 40, 50, and 60. So we want to do scores not between 30 and 60. We go with our tilde brackets here and brackets so that the tilde can affect everything inside of this bracket. Okay. And then run that, and it gives us everything but what is between 30 and 60. Please, we understand. Do we understand this example? Angie. Angela.
Madam,
Yeah.
please, you said select scores between. So I was hoping that you do greater than and less than instead of the greater than and equal to, because between will indicate that the things that are inside 30 and 60.
I
So
mean,
this
yeah.
shouldn't include 30 and 60.
Okay, cool. We can go ahead and do it like that too. But you see this question here. Where is it? You see this question here. We printed scores between 60 and 80, but we went ahead to use these ones. Sometimes it could be inclusive. It did not state inclusive here. So actually the best way would be what you actually said, to just go without these ones because it's saying between, it's not saying inclusive there. So, but I just did it this way because the first example went that way and I just wanted to keep it consistent. But yeah, between this 30 and 60 would actually be, this is not between, let me move this tilde from here. Yes, would actually be scores between 40 and 60. But if it's stated that inclusive, that's when you add your equal signs there. So yes, thank you. Okay. Okay, next example. Angela, this one that your hand is up. Let's continue. Let's do this next example. We are trying to select
Madam, today okay.
oh
Let's
scores grade less than 300 or greater than 2000. So let's go. Sorry. My network. Okay. Was Angie leading us? Who's taking us through this example?
Madam, please, I was doing it.
Let's
So print into brackets.
Mm-hmm.
Sales.
Sales.
Yes. Then another macho bracket. Then the two soft brackets. Then the sales again.
Yeah, copying from here, so you're seeing two soft brackets. It's supposed to be one.
Madam, but you see, oh, madam, be relaxing.
Okay, that's fine. Let's just use one bracket because we only use that bracket. We use that bracket because we were trying to apply that tilde on this. Okay, but it's still fine. You could still have it in bracket. Okay. Yeah, so let's do it. Brackets in here.
Yes. So sales is less than 300.
Mm-hmm.
Close the bracket and use or.
Pipe.
Great. Pipe. Then sales is greater than 2,000.
Down or.
Marshall bracket. Then yes.
That's it. So you just selected sales that are less than 300 or greater than 2,000. So there's the extremes, okay? So we have so everything in here is either less than 300 or greater than 2,000. Okay, that's why we have 200 and 3,000 and 100. Okay, so I need someone that hasn't spoken to take us through the last example. Am I audible? Hello? Can you hear me? Oh, okay. Okay. So please, who's gonna take us? I need someone that's not spoken, someone that doesn't usually, I don't know. Phew. Hmm. Akofa.
Yes, Kezia.
Yes, can you take us through this one? The last
Sure.
example. Okay.
So we can type print ages,
Okay. Ages.
not about 18. So, okay, into brackets, tilde. Wait,
Which bracket?
let's use the list bracket first. Let's use the
Square bracket.
square bracket.
Okay.
Then tilde,
Tilde. Is it tilde or tilde? Tilde. Okay.
okay. Then
So,
ages, into brackets, ages,
need two brackets first. Yes. Ages.
greater than 18.
Greater than 18.
Close
And
bracket.
oh, okay. See why it's just one bracket. It's just one condition.
Then,
Okay.
yeah, then square bracket.
Okay. Ish. Okay. There we go. So we have everything not above 18. 18 is not above 18. 12 is not above 18. 15 is not above 18. Okay, guys. That's it. That's all. Please go and take your break, okay? But the thing is, when you come back, let me stop this. Please, we understand everything, by the way, before you go. Do we understand? Do we understand? If you don't understand, we'll stay here till we understand, though. Do we understand? I'm checking the row. Akofa, David, Samuel, Kezia, Melissa, Akofa, Emanuela, Bernard. Well, Akofa, did you say you're hungry? Okay, so I'm gonna stop recording now. Thank you. Okay, so this is our first exercise. We given the weekly revenue for two shops, shop A and shop B. Our task is to calculate the combined revenue, find the difference in weekly revenue, and add 100 Naira bonus to every week's combined revenue, 100,000 Naira bonus to every week's combined revenue. Okay. This is in thousands. The zeros have been the 3 zeros have been put to the side. So this is 120,000, 135,000, 110,000, and so on and so forth. Okay. This is in thousands. Okay. All right. So I'm gonna start. And so who's gonna start this with us? Everybody's gonna share. Hey, Melissa, how fast? You need to do the easy ones and escape. That's fine. Melissa, let's do task 1.
Please, can you see my screen?
Okay, you're sharing your screen. Let me stop sharing mine. I can't see your screen just yet. Yes, I can see your screen.
Okay, so for the first question, we're asked to calculate the combined revenue per week. So we already have our array of the list. So the combined revenue is adding shop A and shop B. So we have combined is equal to np.add shop A, shop B, and we print our combined.
Okay.
So we have it here.
Okay. Since you
And
have
then
task, let's do.
find the difference is the difference between A and B. So I
Okay.
did difference is equal to shop A minus shop B, and then I
Okay.
printed the difference. And then the last one is that we're adding a 10,000 Naira bonus.
Okay.
But you said the other zeros are hidden.
Yes.
So combined, which is our shop A plus shop B plus
Okay.
the 10,000 Naira, then we print the add 10, and we have this.
Okay. Thank you very much.
Welcome.
Does everyone agree with Melissa? If you have an alternative solution and you'd like to share, let's see your screen. Do you all agree with Melissa's work? Can someone show me an alternative way of doing questioning task 2? I'm coming. I wanna join here and then I saw that Melissa used she added it she subtracted from each other using the subtract operator. So I want to know if there's someone has an alternative solution. Let me share my screen. Okay. So what Melissa did was for the first one, she used np.add. We have shop A, shop B. So we go okay. So we go I'm gonna show the alternative way, right? Since you use np.add, I'm gonna do it the other way. Okay. So we're gonna call it combined. Combined equals, Melissa use np.add, but we're gonna go shop A plus shop B. This is an alternative way to do that. And then we're just gonna print our output combined. Okay. With our outputs. Okay, so can someone do the alternative way? In fact, I'm gonna call somebody. Yeah, I'm gonna call someone. Samuel, are you here? Can we do the alternative way? Melissa did it this way. Can we do the alternative way for finding the difference between the weekly revenue of shop A and shop B? If Melissa did it this way, what is going to be the alternative? This is how Melissa did hers. So how are we gonna do it? Hey. Angela, okay, Lucy, let's hear you.
Hey, I'm trying. No, I'm not
Oh, of course, we are all trying.
doing the NP dot subtract.
Okay. So we go, what are we gonna equate it? What do you want your thing to be called? Your difference?
So let me just refer to my so maybe we can do different. So maybe diff underscore rev
Okay.
something.
Difference equals what? NP dot what?
And the subtract. Yeah.
Okay. And then in there we have what's A and B.
Then we have the
Yeah. Okay. So guys, this is an alternative way to do what Melissa did. Okay. So we found the difference between each value, right? This is the weekly revenue. So I'm guessing this is day 1, day 2, day 3, day 4, day 5. So day 1 minus day 2, day 1 minus day 1 for this next shop, day 2 minus day 2, day 3 minus day 3, and so on and so forth to keep. Okay. And Melissa did the weekly bonus. Let's do with what's called bonus. No, added bonus. Equals combined this one. We are doing adding 10,000 naira to both, right? So combined, and we said that this is in thousands already. So we'll just go with a 10 because these zeros are hidden. So combined plus 10. And then we print our added bonus. Are we okay? Is everyone okay? Okay, so we can move on to the next question. Can we? Okay. Okay, cool. So we have our next question, exercise 2. So Melissa is out. Okay, Ella, let's do exercise 2. You want to share your screen? Or you want to do it on mine?
I'll do it on yours.
Okay, good. Let's go.
Okay, so with the first task, we were told to add 7 to each score. So
Okay.
bonus scores, that's what I
That's
use.
the variable name.
Yes, please.
Bonus scores.
Is equal to scores 7
Scores
plus 7.
plus 7.
Yes.
Print bonus scores to check. And that worked. Okay. Next one, do you want to do that?
Yes, please. So,
Okay.
you have to make sure no score exceeds 100 using the NP minimum array 100. So, capped scores, that's the variable name I used. Hello? Hello? Please, am I audible?
Yes, please hold on. Okay.
Okay.
Sorry, Ella. Let's go.
Okay,
Okay.
so I did it capped scores. That's the
Okay. Tap
variable name.
for,
Yeah.
sorry. Tap underscore score,
Yes, please.
right?
Yes, please. It's
Okay. Wait. Hmm.
NP dot minimum
MP dot minimum. So this is
into the
something, before you go, please let me say, this is one of the functions that I don't think we touched on yesterday. I told you there's a whole lot of NumPy inbuilt functions that you have to read into on your own because we can't possibly cover everything. So this is one of those. And inside of, please give me a second, okay? Inside of MP minimum here, it accepts your array, right? And then your value. Okay, so it makes sure that this array does not exceed this value. Okay, all right, so let's go on, please. Let me just put that up here since it wasn't mentioned yesterday. Okay, so yeah, sorry, let's go.
Okay, so with this one, with the array, I use the bonus scores to the
Okay, okay,
then 100, comma 100.
from 100. So this is our value we don't want it to exceed, right?
Yes, please.
Okay, so we're going to what, print?
Cap scores.
Okay. Okay, good. Thank you. Let's run that. And then since nothing exceeds 100 here, we have what we have in there. Say we had Ella, please give me a second. 100, 103, 107, 200. This cap will turn all of those that exceed 100 into 100. So it works in the case where, say, I want to give the entire class bonus of 10 points, right? And I and then there's some students in there that got, say, 93. If I give everybody 10 points, that student will get 103 over 100. So in this case, let's say this student got 103, right? And everybody else got, someone also got 99, right? We do that. So when we run it, this is fake. What has just happened? See, the person got 90, I meant 99, and then we added 10 points to it, right? So it becomes 109, right? Right. So this cap this value here, this cap minimum will make sure this MP minimum will make sure that nothing inside of this list, inside of this bonus course, will exceed 100, right? So all those that got 90 something and I still give them the bonus because I have to be fair, I still give them one. I'll just use this MP minimum and make sure that everything stays within this 100 limits. See, I don't want any student to get 100. I want everybody to get 99. I can do that, and everyone the highest score is 99. It doesn't exceed 99. Okay. So thank you so much. Let's do task 3.
Okay, so with the task 3, we are supposed to know how many students now passed. That is, students who had greater than or equal to 60. So I did my variable pass.
Let me reverse this thing so everybody's output is the same.
Okay.
Okay. So you made your variable what? Passed?
Yes, please.
Okay.
Also np.sum
np.sum
into brackets the CAPS scores.
This one?
Yes, please.
Yeah.
Is greater than or equal to 60. Then I print the pass down.
So you guys remember what happens with it? Should we print our CAPS scores greater than 60 or return what our Boolean value, right? Let me print that. Or return our Boolean value true, false, true first. And we said true is 1, false is 0. So when we call NP sum on this, we are telling it add up everything in here, right? And if we add 1 plus 1, we get 2. Plus 0, we have 2. Plus 1, we have 3. Plus 1, we have 4. Plus 0, 4. Plus 1, we have 5. Okay, so this should give us 5 after we run it. Let me just wipe this. Then let me print this pass in here. See, we have our 5 in there. So thank you very much, Ella. Please, you guys understand? Do we understand what this exercise? So I don't need a girl to speak at this point. I need
go
to
over.
go over which one? Who said go over, please?
I mean, can you please repeat the explanation for this one?
Can I please repeat? Well, I didn't hear you.
Can you please restate the explanation for exercise? The exercise tax 3, sorry.
Okay, cool. All right. So when we were, let me see. You give me a second, okay? Let me finish explaining
Sure,
his.
sure.
Okay. So we said that, yeah, when we're talking about Boolean comparison, yes, comparison operators, right? We said that when you compare something in Python, right, you compare a value 67 compared to greater than what? 67 greater than 80, then we print this. It's going to return a Boolean value, true or false, right? Because we are comparing, right? It returned a false, right? So whenever you are comparing with these comparison operators in Python, it's going to return you Boolean values, right? So we have this here. This is our operators. So we are comparing our CAP scores. CAP scores is, we can just use our scores, right? We can just use our bonus scores. You don't need to use the CAP scores because nothing really changed with it because since there was nothing above 100, right? So if that is what's confusing you, it's because CAP scores and then bonus scores contain the same exact elements. That is why we are able to use CAP scores or bonus scores, okay? Right. So here she chose to use CAP scores. So CAP scores, we are comparing each element in this array to this 60. So when you take 58, is 58 greater than or equal to 60? You'll do this one by one. Right? We're going to get what? False. Ignore this thing here. We're going to get what? False. So same is done for each element within this array. And when we do this one by one, we have our output, which is true, false, true, false, true, false, true, false for each element. Is it Mohammed asked? Do you agree with this? That when we print, we compare this and we print it, this is our output. Do you agree?
Yes.
Good, good, good. So if we have our array like this, I've told you guys that in Python, true is what? 1. So this is basically what is here. True equals 1. True equals 1 again. False equals 0. True is 1 again. We have another true 1 again. False 0. True 1. False 0. This is what this looks like. Do you agree? Hello? The person that asked me, that's what I'm focused on. Do you agree that this is the same as this? Mohammed. Was it Mohammed? I don't know. I'm waiting for you. If you don't speak, we don't go. I need to hear that you agree. If you don't agree, tell me I don't agree. Let me prove it to you. Is a person here? Hey, uncle.
I'm here.
Now you're asking, am I in that say, hey, who is that? Who is that? Who? Is who? Is it Bernard? Or is Mohammed? I can't tell. Lucy, tell me who is that? Who is speaking? That's not minding us.
I just mind.
You, why? So, please, I'm asking you if you agree that this is the same as this.
Yes, please.
So if we call MP sum on this is the same as this, right? This is what gave us this, right? So if we call MP sum on this, what do you think will happen? You have 1 plus 1 plus 0 plus 1 plus 1 plus 0 plus 1 plus 0, giving us what? 5. So basically, instead of breaking these down, she did it all at once here. This giving us this array of booleans, and then she's called MP sum on them because Python recognizes true as 1, false as 0. So MP sum will look like this. We're calling MP sum like this, and it gives us our output of 5. Please, do you understand now?
Yes, please.
Thank you. We are moving on, right? Please, who's gonna take exercise 3? We need a nigga. Sorry. We need a guy.
Hey. Please, I think I'll take over. I'll
Okay.
do.
Lord, please, before you move to
Oh, sorry, your question. Hey, sorry.
before you
Yeah,
move to go
you said,
so if you were to mark this exercise and then I was to still be working on the scores without the bonus, will I be getting this wrong?
working on the scores without the bonus.
You see, when we added the bonus,
Let
so
me
like the
read
7
first.
to all of them.
Add 7 to everyone's score. Make sure no score exceeds 100. How many students now? So because of this now here, yeah, I think it's like something has changed. So now what's
Right.
the so yes, probably. I'll still not give you wrong because I'll give you probably half because I feel like your code is still correct. You just probably didn't understand the question. I'll probably give you full marks because you didn't really understand the question, but your code is accurate and the code that I care about. So
Okay. Because it does make a difference when you get to the numbers passing.
almost definitely.
Because I
But
got 4.
here 7 is
Yeah.
not added, but here 7 is added.
Right. Okay.
So in this case, there are less. In this case, we have 58 here. So this one is less than. See, this is less than 60. When we add 7, then it becomes boosted to 65. So yes, it definitely makes a difference. Okay, but your code will still be accurate. So I'll probably still mark you correct, or maybe I'll take a little bit off.
Okay. Thank you.
Okay. All right. So we have question 3. Ernest, let's go.
All right. So, hello, can you hear me?
Of course, yes, I can
All
hear
right. Please give me a moment.
Okay.
Okay, so please let's go then. So for the first one, you are told to find the total sales for each week. So for what I did was please write total underscore sales one.
Total underscore sale. Okay, sales what? One.
Yes, please. Yeah, equal to mp.sum week one. Then into bracket, week one. So I did the same for week two, and
The same,
yes,
like this.
yeah, but then this time it was week two. Week two was now the argument. Yeah.
Okay.
Yeah.
Okay.
And then I printed total sales one and total sales two.
Okay, thank you. Task two.
Okay, so for tax two, I also made a variable average underscore week one.
And make it AVG.
Yeah, that's how I made it. AVG underscore week one.
Okay.
Equal to mp dot average. Then week one was now the argument.
MP dot what?
Dot average.
Dot average.
Yes.
Oh, okay. And then what's in there?
Week one.
One.
Yeah. So I did the same for week two. And then I printed them both two as well.
Interesting.
Yeah, sorry, but I rounded in the printing. I added the round function.
Okay.
So round in the printing, yeah. So round and comma. No, I brought the round first. I don't know if maybe your way to work.
I guess
Yeah.
round and then comma what? One. You rounded to how many decimal places?
I even made it zero, so no decimal place, but then it came as a float. So, but then the round, so it was print, bracket open, round, bracket open again, average week, comma, zero.
Okay.
Yeah, so another bracket. Yeah, so I did the same for,
That's one too.
yes.
You know what? I would have used MP mean.
Yeah, oh,
Treated. No, I think it's the same thing. Actually, I guess there are new ones every day. It's the same output, right?
yeah.
Yeah, the same thing. Thank you. Okay, so if you use MP mean, it's still the same thing, okay? All right. Please let's move on to the next.
Madam, please use the mean and let's see if you still get the decimal places. Just try it and let's see.
Okay. Or just print it straight up, huh?
So you get the same thing.
Okay.
Okay, thank you.
You're welcome. Okay.
So for tax 3,
Okay.
yeah, I just created a variable best or best underscore this.
Best underscore days.
Day, sorry, no,
Day.
yeah, and equal to the MP max, and then the variable you created, all underscore days. And then,
Wait, this was created already for you, right?
yeah,
Oh, okay. 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 So what MP concatenates does is it combines the array, right? So it becomes one long array. Let's print. Please hold on. Okay, let me print all these for you guys to see. So we've combined week 1 and week 2, and this is our output. Okay, so that's what MP concatenates does. It's just puts everything in one long array. Okay, please continue.
yeah, and then I printed the best day.
Okay.
And yeah, so I did also for slowest underscore day, and I made it np dot min, then
Okay.
all days, and then I printed that one too as well.
Okay. Okay. Okay, what I put next to is the okay. Action this one. Okay. There we go. Let me make this readable. Okay. So okay. Tax 4.
So, yeah, so that one, I made it avg underscore across or both weeks. Yeah,
Underscore
across.
across.
Yeah,
Okay.
equal to np dot min,
Okay.
then get open all days, all
What
underscore days.
average?
Yeah,
Okay.
and then in the printing, I added the round function.
Okay.
Print round, then bracket open, avg across, comma 0.
Okay. Thank you. See, are we okay? Do we understand? Thumbs up if you do. We need another guy. Another guy, because 2 girls group. We need another guy. Chris, I just saw your thumbs up first. Thank you so much, Ernest. Okay, so please, who's gonna take us through axis operations? Another man. A man. A man. Okay, a girl, because yeah, the men are outnumbered. Hey, should I call you people randomly? Hey, what's happening? Because I understand the answers are right there. Is it that you didn't even look at the question or you are afraid to try? You don't need to take the whole thing. You can take some. Should I call someone? Hey, David. Okay, let's do it. Okay. So, what is our task? This is our column. These are our columns, and this is our row A. In our row names. Okay. Okay. So columns 45, 38, 55, 30, rows 45, 52, 60, and 70. Okay. So what are we first starting with? Find the total annual sales for each branch. So we are summing across what? Columns. And we said that when we are summing across columns, we are summing up the rows because each row is each row is to this is to one row, this is to another row. So this is to Lagos, this is to Abuja, this is to Kano, and this is to PHC. We said that when we are summing across rows because we want to get the total sale for each across columns because we are going like this and the columns we are going horizontal and the columns are vertical. So that's why it says across columns. So we are summing our rows. Okay, when we are summing our rows, axis equals to what? 1. Okay. So we want to get the total per branch, right? So axis equals to 1. Right? Okay, so we just do our normal NP sum. We're gonna call it hello.
Okay. Yes. But yesterday, or how I understood it was that when you are finding the row, axis is equal to 1.
Yes, that's what we are doing.
And
So this is
the
one quarter.
keywords, then
This
in the
thing
question,
here,
it's also
this across thing confuses you. So I'm just gonna take this away, okay? And just continue with our lives, right? This okay, we are summing across the rows because our column is this. This is one column, quarter 1, column quarter 2, quarter 3, and quarter 4, right? And then each row is to the branch. So if you want to say sum up the total annual sales for each branch, annual sales, this is 1 year, this is another year, this is another year, sorry, this is 1 year for one branch, this is 1 year for Abuja, this is 1 year for Kano, this is 1 year for what's that? Port Harcourt, I guess. So Lagos, Abuja, Kano, and Port Harcourt, right? So in that case, you want to sound like this. You know that across thing if it's confusing you, right? Nobody will state in your whatever that sum across this. You're just gonna know that for this task, I'm summing the rows. So I'm gonna use axis equals 1. Okay. Nobody's gonna set questions for you like the way we set questions in real life, right? So if that's across whatever is confusing you, just have in mind that when you're summing your rows, you have axis equals to 1. You're summing your columns, you have axis equals to 2. Hey, 0. Hey. So please, Lucy, are you okay?
yeah, I think that helps.
Let me wipe this thing here too, because I know this one too is doing something to you. Okay, so we have totals equals, we are summing across rows. rows. So x is equals 1. We just use our regular NP dot sum. And then accept our array, which is a say NP, which is sales, and then axis equals 1. That's all. If we didn't add this, it will sum up everything within this array, but we want to sum just the rows. That's why we have axis equals 1k, print totals. Since I've done the first one, who's going to do the second one first? When we run that, we have our, so this, if you sum this up, you have 227. You sum this up, you have 188. You sum this up, you have 255. Sum this up, you have what? 155. Do we understand? This was just yesterday, and today we did a recap. Please not forgotten in Jesus' name. Please understand.
All right. Kizia, please let me try the second one.
Chris,
Nah, Ernest.
Ernest.
No, I was going to say that I wanted to try the second one.
All right. Kizia, take over here.
Okay, Casey, you've not spoken today, so just take one. Somebody, we are giving thumbs up at the corner there. When we call you, you'll be hiding. You are next. Please, let's do. Casey, let's go.
So, sales per quarter. That's what the second question is asking us to find. Total
Okay.
sales per quarter.
Okay.
So, equals NP dot sum.
NP dot sum.
Sales, comma, axis is equal to 0. And then you print sales per Q.
And we have that here. So it has summed up the quarterly sales across all branches, right? All the quarterly sales. So first quarter is here. Is this. Second quarter is here. Third quarter is here. Fourth quarter. And then we go on. All right. Task 3. Branch with the highest total. I've actually not seen these questions. I've not gone through them myself. What's the branch with the highest total? A. Okay. So, okay. So branch with the highest total, right? These are total. Let me call this branch totals, okay? Okay, so branch with the highest total, we're gonna call that what? Best branch, because so the question is asking us, since we have our branch totals here, which of these branches here have the highest? So basically, what is the highest for here, right? Which of these branches have this the highest score here? And we see that that's 255, right? Okay, so we're gonna go best branch equals, we first start with NP dot R max. We said that this is used to find the highest, the index of the highest value, right? Index of the highest value within an array, okay? So we have our array here. Hey, sorry, soft bracket. Our array is what? Branch totals, because we are finding the highest in here, right? Branch totals. Put that here. This alone, right, would give us, let me print it. This alone will give us index 2. Okay, wait, because this is 0, this is 1, and this is 2. This is the highest. Okay. So with this index, right, with this, since this gives us index 2, how do we filter for the branch with the highest total? Look at the branches. We have our list of branches here with Lagos, Abuja, Kano, and PHC, right? How do we make this, how do we make our, how do we derive the branch with the highest total from this branch list, right? We first use this argmax to fish out the index for this branch totals. We know that this is arranged in the order of the branch, right? In the order of the branches, right? Because this, we sum this up to get 277 for Lagos, 227 for Lagos. We sum this up to get 188 for what? Abuja. We sum this up to get 217 for Kano, and we sum this up to get 255 for Kano. We sum this up to get 155 for Abuja, right? Please, do we agree with that before I even move on to anything? Do we agree that we summed all of these to get these values? Because I just did that here with axis equals 1 for row-wise calculation. Cool. So in that case, this is what? Lagos, this is Abuja, this is Kano, and this is Port Harcourt. Abi, good. So this Lagos is what? At index what? 0. Abuja is as what? Index 1. Kano is at index 2. And PHC is at index 3. Right? Index 0, index 1, index 2, index 3. Now we want the name of the branch. We could just stick here and then say, oh, the index is 2. So figure that out. We want the name of the branch. So you're going to use this to filter for our index, right? So we have this, our argmax here. This gave us this 2 here. So this whole thing gives us the value of 2. This is 2. This whole thing gives us 2 because we printed that here and we got 2. Do we agree that this argmax, we found this argmax that we used to find the highest, what's it called? The index of the highest value within our array gave us this 2. So this whole thing gives us 2. We get it, right? Okay. Now let me wipe this. In fact, let me put a star here. Ash, go down. Good. So if you want to filter for the second of this, the index position 2, right? This gives us index position 2. How do we filter for index position 2? We go these branches. Index position 2. This would give us our index. This would give us the location of this. This is the location of this. This fishes out the location of index position 2, right? The item in position 2, right? Please write. Okay. So, and if this gives us 2, right? We're gonna just put our branches here. Then our square brackets here. This is the same as this. This is the same as this. Should we print? Let me just print branches. Hey, what's it? Branches. Print branches 2. We get what? Kano. This is how we filter. We select, pick out a value with this index, right? It's called. It's not called slicing. It's called, what is the counterpart of slicing? I explained this thing to you. Short-term memory loss. Indexing. Thank you. It's got indexing, right? So we have our index here, and we've used it to fish out the position, what comes in index position 2, right? So branches here, square brackets here, this gives us what? Kano. Okay. We agree that this is equal to 2, right? So this and this is basically the same thing, right? Okay, I'll take it again, by the way. Hey, 53, 7 minutes. Hey, you people. In fact, I'll give these two as an assignment. Also, if people have not submitted your group assignments, you've not submitted your group assignment, I will score those there and say that only those people did the group assignment and leave everybody, because I've left it open and some people have not turned it in, because I guess I've not mentioned it again. Please turn it in before tomorrow, before you come here tomorrow. Okay, so that I can grade all of you. Just submit what your group submitted. I'll just look at the group names and give you guys the same score. I don't even look inside to see if you made any changes. I'll give you guys the same exact score because all of you work together. Okay. Back to what I was saying. So when we go, best branch is equal to this is that we print best branch. It will give us what? Hello. Do we understand? This is indexing. If you have a list here and you want to select anything from this list, you want to pull out anything from this list. I want to take out Lagos, for instance, from this list. Please, how will I do it? Put that in the chat. If I want to select Lagos from this list, how would I do it? Kindly put your code in the chat. This is indexing. We did indexing and slicing on week 2. Branches 0. Okay, I need to see more. If those of you who are waiting for someone's answer, then you come and answer. You're right. Thank you. Okay, so branches 0 will give us what? Lagos. Right, we want to pull out Port Harcourt. Please, what would we do to take out Port Harcourt? I need someone to give me the positive version, someone should give me the negative version. Okay, someone gave the positive version of branches 3. So what's the negative version? Branches -1. Thank you. So you remember indexing and slicing. Good. So this NP argmax just gave us that 2. Okay, let me build this again, right? Now that I've reminded you guys of indexing and slicing, we're gonna start again because you will take this as an assignment. I will copy it and assign it to people. This one, yes, it is 8. It's 6. Okay, 5, 6, 7, and 8. It's just 3, 8, 4. Perfect. You can do it. You can do it. You can do it. Okay, in here. So we're gonna take this again, right? We have our. We say we want to find the branch with our. Lucy, dear, she's always shocked. We want to find the branch with the highest total. How do we find the index of the highest value? Right? We go with what? MP dot arg max. If we wanted to find the lowest, we go with argmin, but we're doing argmax because we want to find the highest. Then within it, we have our array here. It goes here, closed. Okay, this is how we fish out for the index of our highest value. Okay, from this. All right, this alone will give us what? 2. We checked it and we found that this alone will give us 2. So if you want to filter, if this gives you 2, this gives us 2, and you want to filter for its corresponding branch, right? We go what? Branches, right? Because we are using this list. branches here, and then we have this NP argmax in here, which gives us 2. We print it, and we have our Kano. If we check here, Kano has index 2, which tallies with our highest value here. Do we understand? So here we've just combined multiple principles. We've
Madam,
combined
please wait.
argmax. Sorry?
Please wait. Please go down. Let me see the answer. You said the answer is Kano.
Yes. Because
We are
Kano is
looking
at
for the highest.
Yes, that's the highest, 255.
No, that's right. Okay. Thank you.
So I should zoom further.
Madam, please, it's okay. I've seen it. Thank you.
Okay. So let's do it for the branch with the lowest total, right? How do we go about that? Somebody. Angela, you asked me to do this, so let's do.
So np.admin,
There we go.
then branch totals,
Mm-hmm.
then print it. So print.
Use this to filter. So
Yes.
branches, and then we print that.
Okay.
All right. Print. And we have Port Harcourt, which corresponds to the value here. Truly, we can see that Port Harcourt had the lowest. Thank you. Do we understand? Do we get it? Do we get it? It's actually time. Should we take task 4? You want to do it as an assignment? You do it here or you take it home? Do you want to do task 4, please? Are you going to give me some minutes of your time to do task 4? Yes. Okay, so we're trying to find what's the best quarter, right? And we said that this is the summation of what our quarters. This is first quarter, this is second quarter, this is third quarter, this is fourth quarter. Do we agree? Ronald, I'm working with you. If you don't mind me, we'll be here. Do we?
We agree.
Okay, nice. So we go MP dot what? Argmax. And we apply that on our what? Sales per quarter. Because this one, we've totaled all of the sales per quarter in there. And then we put that here. And this is our little index finder, right? And I'm going to use this to filter. Right? So we have our what's out here branches, which is the name of our array. Go print. Do we understand this? Do we know why this looks like this? Mind me, it's time for you to go home and continue with your life. So mind me and let me let you go. You get it? You don't get it? You get it? You get it? Okay. So we have MP.argmax. And then we have our sales per quarter here. So we're telling MP argmax, hey, look through all of these, right? And pick the index of the highest one there. We're looking for the best quarter. So the highest one there is going to be what? 251, right? So this argmax should find us index 0, 1, 2, 3, right? So I'm going to print this one first. I'm coming, okay? Go home right now. In fact, you already see. See, it gives us index position 3. Okay, so this is 3. Wipe. We run that and we have what? Port Harcourt. Port Harcourt has our highest. Hey, what's up? No. You should not give us Potter. You should give us Potters. Hey. Sorry. Hey, you are giving me thumbs up. Hey. Yeah. We're filtering through. We're trying to find which quarter has the highest sales. Okay, so we fill that with this one, through this one, and we get what? Yeah, we get our fourth quarter. Do we understand? I don't mind taking it again. Do you understand? Do we get it? It's the same as this. It's just that we are just filtering through our sum of our total the total quarters, the total sales per quarter. We are filtering through that, and we are going to use this to find we are using this index to locate our quarter. And we have a list of quarters here. And if we want to do that, filter to locate any element in this quarter, we go quarters. I'm done. Okay, I'm done. And then we have index. We want to find the first one, right? We go 0 and it's gonna print that for us. We go 1, it's gonna print that for us. So basically that's what this code does, except it goes quarter with 3 in there. Please, do we get it? Do we get everything we've done today? Any questions? Do we get it? Hey, mind you, do we understand? Or you've left me here? Melissa understands. Ernest, Emanuela, Kezia, Dave, Alice, they understand. So 5 people understand. Where are the remaining 11? Lucy, Shirley, Akofa, 8 more.
Hey. I have this thing that is coming up, but maybe we can tackle it tomorrow. Then
Sorry?
let's look tomorrow. I said I have something that's coming up, but then we can tackle it tomorrow. I don't think it's not a problem. So no. I don't know why it's telling me list index out of range. So maybe I'll restart and see what happens. Then
Index
tomorrow
out of range?
yeah.
Share your
List
screen, right?
index.
Please.
Oh,
We are done with today's
everybody's tired. I don't want people looking at me from the corner of their eye, so we can tackle it tomorrow.
No. I'm about to stop the recording. You can leave if you want to leave. But Lucy is going to share her screen, so we'll locate her problem. Okay, so guys, we're done. This is the end of today's class.